So in this lecture, guys, we are going to study divisibility tests and cyclicity. These are two very important points of number theory. In fact, for next few lectures, we are going to study number theory. I have covered basics of algebra. For next few lectures, I will be covering basics of number theory. SPS sir is covering basics of geometry. So these are the three essential elements which you require to basically master IOQM level of mathematics. My name is Prashant Jain, author of 19 plus books, most viewed IOQM educator since last 4 years, mentor of AIR 1, 6 and 22 in ISIB Math 2023, mentor of numerous top 100 ranks in JEE 2023, INCHO gold medalist, INPHO and TSC qualified. So yes, like these are the links, guys. This is my Telegram link. First of all, you should definitely go and like subscribe on this and enable the notification as well, because all the videos related to me you can find on this particular link. IOQM PYQs, assignments, mock tests, you can find here. NSEHSS, NSEP, NSEC, NSEP. So we have free resources for all of you for all the Olympiads. So first of all, what do I mean by divisibility? Right? What do I mean by divisibility? Right? Now, if you ask me, is 1, 2, 3, 2, 1 divisible by 11, right? If you ask me this question, is it divisible by 11, right? So one way to do it is the standard snake technique, like I call it snake. This is a standard snake technique. You divide, right, like this, and this is remaining. So if you have a remainder, then it is not divisible. If the remainder is 0, then it is perfectly divisible. So you can write 1, 2, 3, 2, 1 as 11 times some number plus 1. We are not worried about the quotient. We are not worried about the quotient. We are worried only about the remainder. 1, 2, 3, 2, 1 leaves 1 as remainder when divided by 11. But see, like language wise, it is so lengthy. What am I saying? 1, 2, 3, 2, 1 leaves 1 as remainder upon division by 11. Right? So there are three important numbers in this statement. 1, 2, 3, 2, 1 is an important statement. 1 is an important statement. Is important number. 11 is an important number. 1, 2, 3, 2, 1. What do you call 1, 2, 3, 2, 1? It is called dividend, isn't it? This is called divisor, and this is called remainder, right? Right? Am I making sense here? I should, because there is nothing new in it. Do you all agree? Do you all agree that this is what we call them? Now, in pure mathematics term, in abstract mathematics term, in non-routine mathematics term, in Olympiad mathematics term, we call it 1, 2, 3, 2, 1 leaves 1 as remainder upon division by 11. So we represent this whole situation like this, right? And we say a number A divides B if B is equal to n times A. So basically we are saying remainder is 0. Remainder is 0. Right? We are saying remainder is 0. Right? Right? Remainder is 0. And B equals NA. N and A are divisors of B. Now there is a problem here. Suppose if this number is too huge, 10 digits, 12 digits, let's say 100 digits, then solving using the conventional method will not be appropriate. Let alone appropriate, it will not be optimal. For sure, it will not be optimal, right? we need certain methods for certain divisors, right? We need certain methods for certain divisors to help us ascertain if a very big number is divisible by them or not, right? And that is why we study divisibility rules. That is why we study divisibility rules, right? That is why we study divisibility rules, right? I hope you have written it, right? You can simply write UDAN once you have written it. In all my lectures, you need to attend by with a very good sitting posture, and you should not be distracted because these lectures are of very superior quality. In long run, in some times only in this lecture, we will be dealing with very high concepts, with very high level concepts. So your focus should be here, nowhere else. Okay? 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 Perfect. Then let's write certain rules. Let's write certain rules. Divisibility theorems. Divisibility theorems, right? Important theorem is if A divides B, A divides C, then A divides MB plus NC. This is a very intuitive thing. What am I saying? Essentially, A is divisor of B, A is divisor of C, right? So I can write A as P times B as per the rule which we discussed on the previous slide. I can write A equals, since A divides, this is the symbol of divides, right? When I'm saying A divides B, then B equals P times A, C equals Q times B. Now what is this number? Let's call it N, capital N. Capital N is MB plus NC. Now let's substitute the value of B and C. What is B? B is PA. What is Q? What is C? Q times B. If you, here also it will be A because we have to see A is the divisor overall, right? So PA and QA. So can you see that you are being able to take A common? And again, by this rule, you can see A is written here, N and A both are divisors. So can you say that, okay, A divides N. So this is the proof of it. And it is required. This type of reasoning is always required. Majority of the students understand the concepts of number theory, but they do not understand the proof. The proving is very much essential, especially at the later stages of mathematics Olympiad, that are RMO and INMO. In RMO and INMO, your reasoning should be very, very perfect. So you need to understand it like this. Otherwise, there is no point. Otherwise, there is no point. Otherwise, there is no point. Okay? I hope I am making sense. I hope I am making sense, guys. Right? Perfect. So there is a corollary of it. What do you mean by corollary? Logical conclusion of a statement. Right? So if A divides MB plus NC and A divides B, then A also divides C. Right? What I'm trying to say, if A is dividing this sum and A individually divides B as well, then A divides C. This is a very, very important thing. For divisibility, it is very important. Right? For example, if I have 5P is equal to 25Q plus R, right? Then see, 5 is dividing this number, 5 is dividing this number. What I'm trying to say here is 5 is dividing this whole number. 5 is dividing this. It implies 5 also divides R. It implies 5 also divides R. This is a logical conclusion. Right? This is one example. See, like, we use this. We 100% use this. We 100% use this. Right? Please note it. It is very, very important. And the next page is going to be very, very important too. The next page is going to be very, very important too. Okay. Please note it down, guys. Okay, perfect. Right? Now, let us deal with this question. Prove that sum and difference of two numbers have same parity. Same parity. Now, what do I mean by parity? See, like, parity is basically odd or even. The number is odd or even. So, odd and even are pair. Every natural number, every integer for that matter, is either odd integer or even integer. 0 is an even integer. 1 is an odd integer. -1 is an odd integer. -3 is an odd integer. So, this is a concept which is related to integers. Now, what is the meaning of this question? If you have two numbers, right, you either add them or subtract them. If after adding you are getting odd number, then after subtracting also you will get odd number. If after adding you are getting even number, then after subtracting you will get even number, for sure. This is the concept. This is the concept, right? This is a very, very important concept which is used everywhere, Okay, and I will give you a very amazing problem out of it, which is of the level, which is, I think, like of the level of RMO, for sure. Let's do it, guys. Let's do it. Let's do it. Solution. If you want to try, you should pause the video and definitely try. But I am going to tell you the amazing solution to this problem. Prove that sum and difference of two numbers have same parity. So, we are going to do it with the help of contradiction. Right? Contradiction. We have taken two numbers, m and n. And we are saying that m plus n is even and m minus n is odd. Right? We are saying this thing. So, what we are essentially saying that m plus n is even. So, we can represent it with 2p. Right? Because all even numbers are perfectly divisible by 2. Now, what we are saying is that m minus n is odd, which means that m minus n leaves 1 as remainder upon division by 2. This is the definition of odd and even. Even is perfectly divisible by 2. Odd is something which gives 1 as remainder upon division by 2. 3 gives 1 remainder, 5 gives 1 remainder, so on. Now, if you add them, you get 2m equals 2p plus 2q plus 1. Right? Now, according to the rules which we have already studied, this is divisible by 2, this is divisible by 2, hence 2 should divide 1, which is a contradiction. It is a contradiction, right? And hence, since it is a contradiction, hence both have same parity. Right? Both have same parity. Parity means either both of them are odd or both of them are even. Right? So, in my experience, students do not understand it like this. Sir, this proof is too abstract, right? So always in number theory problems, always take examples first. What is the problem all about? Because when you take the examples, you understand the problem, and the first step to solve a difficult problem is to correctly understand it. It is a very important thing. So let's take any example. M, N, M plus N. I am making a table. Let's take both of them as even. What is the sum? Even. Difference. All I have to do is to check the parity. If the parity here is 0, that is, it is even, then the subtraction is also even. Let's take this as odd and this as even. This is odd, subtraction is also odd, integers. Let's take this as even, this as odd. Again odd, odd. Let's take both of them as odd, right? See, both of them have same parity. 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 In all the examples that you were able to take, these two numbers are of the same parity. So now this is how we have understood the problem. This is how we have understood the problem. And then once we understand it, this is the abstract form. What do I mean by abstract form? General proof. This is a general proof. Getting my point? This is the general proof of it. This is the general proof. Okay. Am I making sense, guys? Am I making sense to you? Am I making sense to you guys? I hope I am making sense. Am I making sense to you guys? Perfect. Okay. So this is about divisibility of 2, right? So this is the basic about divisibility, right? Now, this is a very important problem. Prove that M, N belongs to natural number cannot satisfy 2m plus 1 into 2n plus 1 equals, or let's just say m square minus n square equals 6. Cannot satisfy. Now m and n are natural numbers, right? What I'm trying to say, 6 cannot be represented as difference of two perfect squares. I'm simply saying this thing. So this question can come it like this also. So in these type of problems, what we have to do, we have to approach through divisibility, basic rules of divisibility, right? If you want to try, you can pause the video and you can try, right? If you want to try, you can pause the video and you can try. Now, this is, if I factorize it, m plus n and m minus n is equal to 6. Now see, these are the two numbers. Addition of two numbers and subtraction of these two numbers. So either both of them will be odd, which cannot be equal to even. So this case is rejected. If both are even, it has 2 as one factor. So in the multiplication, you will have two factors of 2, right? What I'm trying to say here is Just take any two numbers which are divisible by 2. Let's take 6 and 18. So if you multiply them, you have 2 to the power 1 here. You have 2 to the power 1 here also. So in their multiplication, you will have 2 powers of 2, right? So even into even is actually should have 2 powers of 2, but 6 only has 1 power of 2. So this is also a contradiction. It implies no solution, right? So these are certain advanced applications, but these applications are important so that you understand the basics of divisibility, right? So that you understand the basics of divisibility. Okay. 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 Right? Perfect. Perfect. Let's do this question. Let's do the next question. Let's do the next problem. Let's do the next problem. Right? This is the last one, and then we will go on and study divisibility rules and cyclicity. Right? This is the next question. Prove that a 7-digit number is divisible by 9 only if its sum of digits is divisible by 9, right? So essentially what I'm trying to do, I'm trying to prove the divisibility test of 9. We are trying to prove divisibility test of 9. Okay, we are trying to prove divisibility test of 9. Okay, let's try to do this. Now you need to understand carefully what the question is asking, right? Like I said, think of a number which is divisible by 9. Okay sir, 225 is divisible by 9. Now what is its sum of digits? 2 plus 2 plus 5, which is equals 9. Yes, the sum of digit is also divisible by 9, and hence it should make sense. So let's try to prove it. Now it is a 7-digit, like 7-digit number is just a representation, right? So first of all, 7-digit number is represented like this, right? Now when you represent number like this, it is called decimal system. Which means that this number can be expanded in the form like this, expanded form, right? Why it is called decimal digit? Let me explain you. But first of all, let me write it. Right? You must have seen this expanded form. Now here, these AIs can be 0, 1, 2 to 9. So since AI has 10 possible values, 0, 1, 2, like these are digits, right? And since it is a 7-digit number, so we can say that A1 will not be 0. But let's leave that aside. AI can take 10 values, 10 possible values. What do we call 10 in Greek language or Roman language, whatever you call it, deci, right? Dec means 10. So that is why we call it a decimal system, since we are using 10 digits. If you represent any number, right, whatever be the number, your Instagram followers, whatever the number you can choose, you use 10 out of the 10 digits, you use certain digits to represent that number, right? And that is why it is called decimal system. Now, if you see this number, I can write 10 to the power 6 A1 as this, 999,999 A1, and let's write A1 here, plus 99999 A2 plus A2, 9999 A3 plus A3, 999 A2 plus A2, oh sorry, A4, my mistake, 99 A5 plus A5, 9 A6 plus A6, and then plus A7, right? If you see, this is my whole number. Now, if you carefully observe, this number is divisible by 9. 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 And this number is divisible by 9. Since this whole thing is divisible by 9, I can say that this sum is also divisible by 9. Right? According to the rule which we have just written. Right? Divisible by 9. And that is what we needed to prove. This is what we needed to prove. Divisible by 9, right? Sum of digits. This is sum of digits only. We write it as Sn. Sum of digits is represented as S of n. Right? Where n is this number. So, see, if you carefully see this proof, this can easily be extended to 8 digits, 9 digits, or any number of digits. Right? And hence, I am of the 100% opinion that this proof, like you will be able to use this proof to actually write the general proof of it. If you have written it and if you are seeing this lecture in recording, do leave a comment here so that I know that you are learning from these lectures. Please do it. Okay. Okay. Yes, Yuvika, Yash. Right? Now, yes, like you are saying, you are rightly saying, sir, divisibility test of 9 is very simple. We have studied in class also. But what about divisibility test of 11? So, should we do divisibility test of 11? Should we do divisibility test of 11? Actually, in one of my lectures, I taught you the concept of, if you have seen that lecture, I have taught you the concept of divisibility test of 11 also. Right? If you have written it, just write UDAN. Perfect. So guys, these lectures are every Monday. Every Monday we schedule these lectures, and all you have to do, if you are not getting the notification, it means you are not on this channel. Right? Right? So so first of all, let's write the divisibility test which you need to remember. 2. Last digit should be divisible by 2, right? Should be divisible by 2. By 2. 2 to the power k. Last k digits should be divisible by 2 to the power k. What does this mean? That if you want to check 8, for 8, then last three digits should be divisible by 8. And it is not something which is like random. It is not random, right? Why this work? Because 2 to the power k or 5 to the power k, same, right? Should be divisible by 5 to the power k. Why does it work? Because if you have any number, let's assume that you have this 6-digit number, right? You can write this number as 1000 time ABC plus DEF. This is a 3-digit number. These are digits. So now this number, because of 1000 is 2 to the power 3 into 5 to the power 3. It is divisible by 2 to the power 3 and 5 to the power 3, which means that these 3 digits are immaterial. All you have to check is these 3 digits, right? So let's take an example. 729,120. Is it divisible by 8? These digits do not matter. Just check for this 120. 120 is 8 times 15, and hence this whole number is divisible by 8. So this is the general proof of 2 to the power k or 5 to the power k, right? We check for these many digits. For 3 and 9, we do sum of digits should be divisible by 3, 9. If we talk about, see, like we have done 2, we have done 3, we have done 4, we have done 5, we have done 6. For 6, you have to check divisibility by 2 and 3. So basically, its last digit should be divisible by 2 and the sum of digits should be divisible by 3. 7, we do not study. 8, we have studied. 9, we have studied. 11, very important. Sum of digits at even places minus sum of digits at odd places should be equal to 11 times q. Should be divisible by 11, right? It should be divisible by 11, right? 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 Yes, obviously this is in my book. Right? So let's try to do 11. Let's try to do 11, right? Divisibility test of 11. And again, I am going to explain you first. So let's take two numbers. 2, 3, 4, 5, 7. So 2 plus 4 plus 7 is how much? 13. 3 plus 5 is 8. Right. Now, this is first place, this is second place, this is third place, this is fourth place, this is fifth place, this is sixth place. So these are odd digits. Let's take the sum at odd digits. This is equals to 13, isn't it? Let's take sum at even digit. 3 plus 5 plus 5, 13. This implies that the number is divisible by 11. Divisible by 11. Now, why is it working? I'm very curious to know this. I'm very curious to know this. Why does it work? Right? So again, I will write it as this. Right? 2 into 1, 2, 3, 4, 5. Right? Plus 3 into 1, 2, 3, 4. Plus 4 into 1, 2, 3. 5 into 100. 7 into 10 plus 5. Right? Now, what do I know? That if I have even times 9, then it is divisible by 11 for sure. Then it is divisible by 11 for sure. So what I'm trying to do here is that I can write 1 lakh as 99990 plus 10. Because see, like, I always have to make 9 even number of times. And then 1, 2, 3, 4 as 9999 plus 1. This is the rule which I am going to follow. So 2 into 99990 plus 10 plus 3 into 9999 plus 1 plus 4 into 990 plus 10 plus 5 into 99 plus 1 plus 7 into 10 plus 5. Okay? Okay? I am making sense here. Now, very simple. Let's isolate these numbers which are divisible by 11. Right? Once you do that, you are left with 2 into 10 and I am representing them by 11 cube, which is divisible by 11. So I am left with 2 into 10 plus 3 into 1 plus 4 into 10 plus 5 into 1 plus 7 into 10 plus 5 into 1. Right? This is divisible by 11. Now, I will add 2 here. I will add 4 here. I will add 7 here. And then I will subtract minus 2, minus 4. I will do this. If you carefully see, this number now becomes 11 times 2. This number becomes 11 times 4. This number becomes 11 times 7. And hence, this number is also divisible by 11. And what are you remaining with? You are remaining with this 3. You are remaining with this 5. You are remaining with this 5. And you have this. So basically, since this is divisible by 11, this is divisible by 11, this should also be divisible by 11. And this is the proof of divisibility of 11. Now that you have done it using an example, you can replicate this proof using general values. For example, you can just assume them as A1, A2, A3, A4, A5, A6, and likewise, you can prove it. This is the same mechanism which you are going to do, and this is your homework as well. This is your homework as well, right? Please note it down. Please note it down. This is the general proof. Right? Yes, if you have secured 75 marks in RMO, you can directly get admission in SRG batch. Perfect. Right? Now let's do a problem related to 7. Let A and B are 2 digits so that this is 3 marker. this is 3 marker. So that 2, 3, A, B, 5 is divisible by 7. Is divisible by 7. Find number of such numbers. Right? This is 3 marker. As per the new difficulty of IOQM. If we take old difficulty of IOQM, then this is 2 marker. But as per the new difficulty of IOQM, this is a 3 marker. Let A and B are 2 digits. So that 23AB, 23AB5 is divisible by 7. Find number of such numbers. So basically, you have to find number of 5-digit numbers in which first digit is 2, second digit is 3, third digit is something, fourth digit is something, and next digit is 5. Right? So such 5-digit numbers which are divisible by 7. Please try. Please try. Please try this. Usually, such problems come with a warning, do not try this at home, but I'll say, let's try it at home. That's all, boys, girls. Tell me, please. So let's do it. Let's do it. If you want to solve it, you can again pause it. And again, I am going to tell you the importance of proving. Right? I told you the proof using the expanded form. So, can I write this number as 23005 plus 10 times AB, which is tan A plus B? Right? How did I come to this conclusion? Very simple. I am writing this in expanded form. Right? So I just simply added these numbers and like this. So let's talk about 23,005. Now there is some manual work here. If I divide 23,005 by 7, I get, again, I'm not worried about the quotient. Quotient is not going to help me. 45. So this number leaves 2 as remainder. So I can write it as 7q plus 2. Now 100a can be written as 98a plus 2a. 10b can be written as 7b plus 3b. Right? This is divisible by 7. This is divisible by 7. This is divisible by 7. It implies 7 should divide 2 plus 2a plus 3b. Am I making absolute sense here, guys? This is the actionable information. This is the actionable information. This is that information on which you can act and you can find the value of A and B. Otherwise, it will be hit and trial, isn't it? It will be hit and trial only. It will be hit and trial. Right? One way to see, I am going to give you an alternate solution also to this. I am going to give you an alternate solution to this also. Right? I'll give you a smart solution to this, but it will require it requires some brain power. But this is the general way to do it. This is the general way to do it. Remainder is 3, not 2. Okay, remainder is 3. So you can write 3 here, you can write 3 here. My bad, my bad. You can write 3 here, you can write 3 here. Okay? Perfect. 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 Is it okay now? Is it okay now? Is it okay now? Is it okay now? Perfect. Now, one way to do it is using indeterminate equation. Right? I am going to write this as 7, 3 plus 2a plus 3b equals 14. 3 plus 2a plus 3b equals 21. 3 plus 2a plus 3b equals 28. 3 plus 2a plus 3b equals 35. Now, why it will not go above 35? Let's see the reasoning. Why? One more, it can go further higher also. But see, a and b can be highest 9. So the highest sum can be 48. 3. 2 times 9 is 18. 18 plus 3 is 21. 21 plus 27 is 48. So we have to take till 42. I am going to take here. Or let's use the other page. Let's use the other page. We do not have dearth of resources. So 2a plus 3b plus 3 equals 7 means 4. Right? So you can see here 2, 0. That's it. This is the only solution. Right? This is the only solution. Right? 2a plus 3b. See, right? My question was this. 7 times q. So if I take q as 2, which means 14. So this becomes 11. Right? Now, we have to find it actually. Yes. So if b is 1, a is 4. And then what do? We add, I think it will be 1 solutions only. No. This. 6, 1, sorry. You add 2 here. 1, yes. 2 solutions here. Because if you again, see, like I am solving it using indeterminate. What was the technique here? You find 1 solution and then you subtract the coefficient here and you add this coefficient here. Now the next is 2a plus 3b equals 18, which is fairly simple because I can start with 6 here. 0, 4, 3, 2, 6, 0, 9. Right? 1 solution here, 2 solution here, 4 solutions here. Then 2a plus 3b equals 25. Now this is going to be tricky. This is going to be tricky. This is actually going to be tricky. Right? But let's do it anyway. 2, 3. If I take b equals 1, then my a is coming out to be 11, which is not possible. So let me start with b equals 3. Right? So that is a 9. 25 minus 9, a becomes 8. And then simply you have to subtract coefficient of 3 here, coefficient of b here. Right? Like this. Okay. So these are the 3 solutions. Now 2a plus 3b. 35 means 32. Again, b equals, so this is even, so b has to be even. So b equals 4, not 4. B equals 6, 18. This becomes 14, 7. Right? This becomes 7. And then 4, 8, 1, not only these 2 solutions. Right? 2a plus 3b. Last is 39. Last is 39. Right? So this is divisible by 3. Hence, a has to be divisible by 3. So this becomes 9. 18. 9 2s are 18. If you subtract 18 here, this becomes 7. right? So these are so high numbers. So this is going to be a unique solution. Unique. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 solutions. Do you agree here that these are the solutions? Do you agree here? Do you agree here? A equals 1, B equals 3. A and B cannot be same, so 5, 5 is not a possibility. Where we have written it? Where have we written it? Where have we written that A and B cannot be same? Where have we written it? Don't presume anything. You cannot presume anything. Right? 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 So these are 1, 2, 3, 4, 5, 13 solutions. Now, see, this is a general method, but there is a way. There is a way. Right? There is a way. There is a way. Let us find the smallest number. Let us find the smallest number which is divisible by, so let's take this number 23065, right? Is it divisible by 7? 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 Please tell me, is it divisible by 7? 23065, is it divisible by 7? The magic is about to happen. Don't worry, the magic is about to happen. Now, if I add a number 70 to it, this is divisible by 7, this is divisible by 7, and since I have 0 here, it will not alter this digit. It will not alter this digit. It will alter only these two digits. So, I simply have to add 7 here. Just keep on adding 7 to these two digits. 13. Right? And keep on adding till you get 2 digits. See, I'm simply blindly adding. Right? Keep on adding till you have 3 digits, 2 digit. 7975. Right? How many numbers did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Which means I have done a mistake somewhere. I have done a mistake somewhere. 9, 0 is solution, 8, 3. Or did I get 4 solutions? 0, 6, 1, 3, 2, 0, 2, 7. Where is 2, 7? 2, 7, 3, 4. 3, 4. Where is 3, 4? 3, 4. 4, 1, 4, 1, 4, 1, 4, 1, 4, 8. Or did I count it wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 14 solutions. 9, 0, 8, 3. Where is 8, 3? 7, 6. Where is 7, 6? 6, 9. Where is 6, 9? Oh, my 6, 9 solution is missing. 15. 2A, 12. 6, 9 should come where? Where 6, 9 should come? Six, 9 solution should come where? I think here. I missed here. Is it? No. 2A, 12 plus, oops, 6, 9 should come here. You have to subtract 3 here and add 2 here. So it's 14 solutions, right? 14 solution, my mistake. So 14 solution, and you are getting 14 solutions here also. Can you check? Can you check? Sir, they all are divisible by 7. See, like you need to understand this thing, that if this is divisible by 7, this is already divisible by 7, I am adding a number which is divisible by 7. Right? Which is divisible by 7. No. There is no problem related to divisibility test of 7. Divisibility test of 7 is simply out of sorts, right? Perfect. Perfect. Right? Please write UDAN. If you have understood it, please write UDAN, understood, done and noted, so that I can move on to the next problem. I can move on to the next problem. Perfect. Now, let's talk about what do I mean by cyclicity? What do I mean by cyclicity? And cyclicity is something which I am simply going to define, but we are going to continue this in next lecture. So, last digit. What are the last digits, right? Basically, cyclicity means we have to ascertain the last digits. So, if number is of the type 10q, 10q plus 1, 10q plus 2, 10q plus 3, 10q plus 4, 10q plus 5, 10q plus 7, 6, sorry, 10q plus 7, 10q plus 8, 10q plus 9, right? So these are the only 10 possibilities. Either the last digit is 0, either the last digit is 1, either the last digit is 2, either the last digit is 3, and so on, right? So this is, and here I am going to write powers. If power is of the type, this is last digit, this is powers, right? This is 4k plus 1, this is 4k plus 2, this is 4k plus 3, and this is where I am going to write cyclicity. And then with example I am going to tell you what is the meaning of cyclicity. So 4k, any power, right? And here some examples also. If you take any power of 10 or any number with last digit 0, last digit will definitely be 0, right? So since it is repeating for every integer, it is repeating, right? So what do I mean by 4k, 4k plus 1, 4k plus 2, 4k plus 3 here? The power is divisible by 4. The power is leaving 1 as remainder upon division by 4. This power is leaving 2 as remainder upon division by 4. This power is leaving 3 as remainder upon division by 4. Right? This is what we need. This is what we need. Okay. So 0, 0, 0, 0. Now, if you talk about 10q plus 1, you will find that the last digit will always be 1. See, 11 to the power, let's say 5. It will be, the last digit will always be 1. So this cycle is 1, this cycle is 1. But this is where the fun is. 10q plus 2. And to analyze it, just think of the smallest number with last digit 2. That is 2 only. What is 2 to the power 1? What is 2 to the power 2? What is 2 to the power 3? What is 2 to the power 4? What is 2 to the power 5? 2 to the power 5 is 32. 5 is of the type 4k plus 1. 5 is of the type 4k plus 1. So last digit will again be 2. So this cycle is repeating. Now what is the length of this cycle? 1, 2, 3, 4. Right? If you talk about 3, 3 to the power 3, 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 7, 3 to the power 4 is 1, 3 to the power 5 is 243, which is again 3, again the cycle is 4. If I talk about 10q plus 4, 4 to the power 1 is 4, 4 to the power 2 is 16, 4 to the power 3, that is 64, is 4, and again 6. So 6, 4, 6, 4, the cycle is 2. So because it is repeating in pairs, right? 5, again 5, 5, 5, 5, cycle is 1. 6, 6, 6, 6, 6, cycle is 1. Right? What is 7? 7 to the power 1 is 7. 9, 3, 1. 4 here again. 8, 8 to the power 1 is 8. 8 to the power 2 is 64. 2, 6. 4. What is 9? 9 to the power 1 is 9. 1, 9, 1, that is 2. So this is the cyclicity. This is the cyclicity. It repeats its unit digit after every fourth power. Fourth power, 2 power. This is such a beautiful pattern. 1, 1, 4, 4, 2. 1, 1, 4, 4, 2. Such a beautiful pattern, isn't it? Such a beautiful pattern, isn't it? Right? Right? So in the next lecture, we are going to do problems based on cyclicity, and we are going to take it to a very high level. Right? We are going to discuss problems on divisibility as well. Right? Oh, hello. Hi guys, how are you? So this lecture is continuation to the past lecture which we did for divisibility and cyclicity. We are going to do amazing problems in cyclicity and divisibility, like I said. Right? I told you last time that at this lecture, the next lecture is going to be super amazing because we are going to see some amazing problems, some PJ exclusives as well. PJ exclusives are the problems which are created by me to puzzle the learners, right? So let's begin with cyclicity. Okay, so I am going to start with a introductory problem. Find last digit of 2 to the power 2024 plus 3 to the power 2024 plus 4 to the power 2024. Let's find it. We need to find the last digit of this number, right? This is also remainder upon division by 10. Remainder upon division by 10. So let's just think. If you divide anything by 10, the remainder that you get is the last digit. If you divide the number by 100, the last two digits are the remainders, right? For example, if I take the example, if I divide it by 100, I can certainly see that 42 is the remainder, right? 42 is remainder. Getting my point? Getting my point here? So, when you are asked last digit, last two digit, last three digit, it essentially means you are being asked the remainder upon division by 10, 100 or 1000, right? Or you can say mod 10, mod 100, mod 1000, like the terminology which we developed in the last class. So, can you tell me the working rule for such problems? What is the working rule for such problems? Let's think. Working rule for such problems. Let's discuss the working rule for such problems. First of all, identify the power. Power is 4k, 4k plus 1, 4k plus 2, 4k plus 3, right? 4k, 4k plus 1, 4k plus 2, 4k plus 3. The essential part here is, in fact, very essential part here is to understand what are these four numbers. 4k means divisible by 4. 4k plus 1 means when you divide the number by 4, you get 1 as remainder. For example, if I talk about 2024, it is of the type 4k, right? Now, just remember the cyclicity. The cyclicity table which we made in the last part of the lecture, right? The cyclicity, right? So, if I see 2 to the power 1 gives me 2, 2 to the power 2 gives me 4, I am just writing the last digit. 2 to the power 3 gives me 8, 2 to the power 4 gives me 6. Only last digit, I am writing only the last digit. Now, I can see that if the number is divisible by 4, my last digit is 6, which gives me that 2 to the power 2024, the last digit is 6 only. If I talk about 3 to the power 2024, again, the last digit is 1. Because 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 7, 3 to the power 4 is 81, but the last digit is 1. Similarly, 4 to the power 2024 is 6. Now, if I add the numbers, just see, like I am giving you three numbers, three random numbers, 234, 448, 365. Now, if I have to find the last digit of the addition of these three numbers, these digits are immaterial to me. What I have to do, I simply have to add these three digits, which are the last digits basically. 4 plus 8 is 12, 12 plus 5 is 17. What is getting carried over, I don't care. But my last digit will be 7. Hence, in this case also, I just have to worry about individual last digits and then I'll just add them up to get 3. Getting my point? 3 is the answer. 1 is not the answer. How can you get 3? How can you get 1? Sid is getting 1, Ojas is getting 1, but it is wrong, right? The answer is 3. I think the answer is 3. Answer is 3, right? Piyush Mishra is confirming that the answer is 3, which is good. Good. 3 to the power 2024, last digit is 9. No. See, what is the cyclicity of 3 to the power 3? Select 3 to the power 1 is 3. 3 to the power 2, I'm just writing all the numbers. 3 to the power 3 is 27. 3 to the power 4 is 81. 3 to the power 5 is 243. So, if you see, there is a cycle in last digit and that is the reason why we call it cyclicity. What is a cycle, right? It repeats. So, 3971, 3971, 3971. It has a cyclicity of 4. That is the basic meaning of cyclicity. Right? Sir, I have a question. How much time should I spend on each problem of your book before I go to the solution? See, like if you are in class 8th or 9th, you should devote 10 minutes per problem and then you can move on to the solutions. Right? Perfect. Have you noted it down, guys? Can you write UDAN? UDAN. We'll implement this algorithm again. UDAN means understood, done and noted. Understood, done and noted. Perfect. Let's move on to the next problem. Find last digit of 2 to the power. Now this is going to be interesting. 2021, 3 to the power 2022, 4 to the power 2023, 5 to the power 2024, 6 to the power 2025. Let's see if you can find it. All you have to do is to apply the algorithm which I have just told you. Find the nature of power. If it is 4k, 4k plus 1, 4k plus 2 or 4k plus 3. Then look at the cyclicity table. Do it and give me the answer. Sir, I have a question. How much time should we? I have already answered it. Six. Let's see. Now 2021 is of the type 4k plus 1. You have to understand how I am getting it. I am getting it through divisibility rule. What was my divisibility rule? I just have to check the last two digits. If I want to check the power, if I want to check the remainder upon division by 4, I just have to check the last two digits, right? So it is equivalent to 2 to the power 1. This is, I am writing equivalent, right? Equivalent. That 2 to the power 2021, and what is the way to write it? 2 to the power 2021 is congruent to 2 to the power 1 mod 10. This is how do we write it. What does this mean? That upon division by 10, 2 to the power 1 will leave same remainder as 2 to the power 2021, right? This is the meaning of it. Similarly, this is equivalent to 3 to the power 2. This is equivalent to 4 to the power 3. This is equivalent to 5 to the power 4. In fact, you can write it, 5 to the power 4 is okay. 6 to the power 1. Because 2025 is again 4k plus 1 type. Now, simply 2 to the power 2021, 3 to the power 2022 is congruent to 3 to the power 2 mod 10. 4 to the power 2023 is congruent to 4 to the power 3. Now 4 to the power 3 is 64. So I am just going to write the last digit of it, because eventually I just have to find the remainder upon division by 10. So I just have to look at the last digit. I am ignoring the 10th digit, that is 6. In 64, 10th digit is 6. 5 to the power 2024 is congruent to 5. 6 to the power 2025 is congruent to 6. If you remember, last digits of all powers of 6 was 6. Last digit of all powers of 5 was 5. Right? Now, so you simply add it. What do I get? I am getting 2 here. I am getting 9 here. I am getting 4 here. I am getting 5 here. I am getting 6 here. 15 plus 2, 17. 17 plus 9 is 26. Again, I just have to worry about the last digit. That is 6. You get the answer? Oh, just Jan, again you have made a silly mistake, it seems. See, nothing is more hurting than a silly mistake based out of addition. How come 9 in 3 power? See, this number is of the type 4k plus 2. 4k plus 2 means you have to ignore 4k. 3 to the power 2 is 9. So last digit is 9. Right? Right? Am I making sense? Correct? Please write, see, like whatever mistake that you make, if you had an observation problem, if you missed out on something, just make sure of it. What do you have to do in your class notes? You just have to mark it. I got this wrong. Just mention it. If you mention your errors, you tend to not repeat it. I have seen it. I have seen it empirically. If you do not mention these things, then you tend to repeat your mistakes. Just like rectangularize it and mention your error. Whatever the error is, I got this wrong. Right, I did not know this. Whatever you want to write it. Right, whatever you want to write. And then simply write UDAN. 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 Just simply write UDAN. Understood, done and noted. Next class of Nimbus is on Wednesday. It is on every Wednesday, guys. I don't know why there is disconnect. Right? Perfect. Let's move on to the next problem. Now, I am going to make things a bit difficult. Right? I am going to make things a bit difficult. Right? Let's see. Let's see. Find last I think it is going to be tricky. Let's see. Yes, this is going to be a bit tricky. Let's see. Find last digit of the number 7 to the power 2 to the power 16. Let's find this out. Let's find this out. This is tricky, but simple. This is tricky, but simple. 7 to the power 2 to the power 16. This is what is written. Yes, this series is highly relevant for ISI also. IOQM is part of ISI. Number theory is asked. Piyush Mishra says 9. I like your song, by the way, Piyush Mishra. The song Arambh Hai Prachand by Piyush Mishra. I really like it. 1. Brahmachari is saying 9. 7, 9. All those, like you have given me all the options, all the available options. 1, 7, 9. Someone gave me 3 also. Because these are the possible 4, like these are the 4 possibilities, right? Right? Let me get going. Now, important part to see here is, this number is 100% divisible by 4. 2 to the power 16, I don't know. See, like, I to know that this is 65536. But you don't have to know about it. 2 to the power 16 is 65536. I know power still, like I know 16 powers of 2. I remember it. But you don't have to remember. All you need to know is that this is 100% divisible by 4. So it is equivalent to 7 to the power 4k. And hence, I can say its last digit will be 1 only. What was 7 to the power 1? What was 7 to the power 2? What was 7 to the power 3? What was 7 to the power 4? This is the cycle of 7. This is the cycle of 7, isn't it? Isn't it? Am I making sense, guys? Am I making absolute sense? Am I making absolute sense? When do we start physics? Physics is going to start soon. You don't have to worry about it. We have all under control. Got it, guys? Done, guys? Perfect. Let's move on to the next problem. But now this time, this is something in which I want you to like do it by pattern, right? Because I am going to give you something which I have not really taught you, and that is the way to teach. I think, like, if you are aiming for mathematics Olympiad, right, then you should also be able to make some theory of your own. So I'm trying this, right? Give me last two digits of 6 to the power 2024. I have not taught you this thing. Last digit is 6. We all know it. But what is 6 to the power 2024? The hint is try to find some 6, 7 powers of 6. 6 to the power 6. What are the last two digits of 6 to the power 1? What are the last two digits of 6 to the power 2? What are the last two digits of 6 to the power 3? What are the last two digits of 6 to the power 4? And then you will find pattern. Let's see if you can do it. Let's see if you can do it. Six to the power 2024. Let's see, guys. Let's see. Six to the power 2024. Are we able to do it? $96. Now let us see. Let us see. See, 6 to the power 1. 6 to the power 1 is 06 mod 100. Right? I am going to write just last two digits. Right? 6 to the power 3 is 16. Now this we know. Now what is the brilliant part? Let me tell you the brilliant part. To find what are the last two digits of 6 to the power 4, you just have to multiply 6 in this. So what is 16 times 6? 96. 6 to the power 5. Just multiply 6 to 96. What is 96 times 6? 6 6 are 36. 6 9s are 54. 5 76. So 76. Right? Now what is 6 to the power 6? Just multiply 6 with 76. This digit does not matter. 6 6 are, 6 7s are. Now you see a beautiful pattern. What is that beautiful pattern? 6 6 6, 9 7 5 3, 1. Getting my point? Again 9 6, 7 6, 5 6, 3 6, 1 6. Nice cyclicity of 5. See, this is 5 cyclicity. Can you see it? Very beautiful problem. 5 cyclicity. Right? So in this way, what I am going to write, if your number is of the type 6, 5q plus 2, your last 2 digit will be 36. 6 to the power 5q plus 3, your last 2 digit will be 16. 6 to the power 5q plus 4, which is this number, your last digit will be 96. And hence your answer is 96. Can you see it? See, like this is, you will say, sir, this pattern is not being followed here, but this is the first digit. This is exception. You can ignore it. Just see the pattern from 6 to the power 2. Are you able to make sense of it? So, see, like, try to understand the process first. What I'm trying to do here, I'm simply multiplying to get the higher powers of 6, to get the last 2 digits of higher powers of 6. I'm simply multiplying to the last remainder. Last remainder was 36, multiplied by 6, multiplied by 6, multiplied by 6, multiplied by 6. Simply write last 2 digits. That's it. And then you saw the pattern. 9, 7, 5, 6, 6, 6 is like it is repeating. 9, 7, 5, 3, 1, 9, 7, 5, 3, 1. That's it. See, like after some time, we will have a definite way to do it. We have a definite way to do it, right? It will be done using a very famous theorem, Chinese remainder theorem. It's a very famous theorem, but that is something which, Chinese remainder theorem, this is something which we are going to do after some time. After some time. It is not something to be tackled today, right? It is not something to be tackled today. But do you like it? Do you like it or not? Do you like it or not? Right? Please, please, please mark this. This is a very exclusive method, by the way. This is very exclusive method. In majority of the lectures that you see online, you will find the solution of this problem using CRT, which is lengthy. It is not pattern based. It is not number sense based. But if you see this solution, this is very, very beautiful. It is number sense based, right? Sir, why every theorem is from foreign? No, it is not like that, right? It is not like that. Have you heard of Fibonacci sequence? It is also called Hemchandra series. It is also called Hemchandra series. Hemchandra is Indian, right? Have you heard of Pythagoras theorem? It is also known as Bodhayan series, like Bodhayan theorem, Bodhayan sutra, right? Area of cyclic quadrilateral. Area of cyclic quadrilateral is Brahmagupta formula. So there are many Indian formulas also, right? Let's move on to the next problem. Let's move on to the next problem. Find last two digits of let me write it, 2 to the power 20, 25. Let's do it. Let's do it. So 32, 2. Let's see. Now, I am going to tell you a very amazing silver lining here. Very amazing silver lining. Right? See, there is a problem which was not here. There is a problem which was not present here. in this problem, our last digit was fixed. But in 2 to the power something, our last digit is also changing. This is a problem. How do I tackle it? How do I tackle it? Let's see. Sonal is saying 32. Brahmachari is saying 32. Oh, I don't think. Just a second. 24, 576, 76 into 76 into 32. 2, 9. 32 sevens are. What is 32 times 7? 19 in fact. 192, 224. 224. Yes. 32 is correct answer. 32 is indeed correct answer. 32 is indeed correct. But let me tell you how. Let me tell you how did these guys got it. Can I write it? Just a second. Can I write it as 2 into 2 to the power 2024? Then can I write it as 2 to the power 2 into 16 to the power? See, 2 to the power 2024 is equal to 2 to the power 4 times 506. Right? Why I am converting it into 16? Because it will give me last digit as 6. Now, let's write 16 to the power 1. 16 to the power 2. 16 to the power 3. Ah, nice. I have got a nice pattern. Right? 96, 16 to the power 4 is going to be 36. Just I am adding 4 here, 4 here, 4 here. Right? So what is this? 506. 506 is 4q plus 2. Right? You can see here the cyclicity is of no. It is 76. 16 to the power 6 is again 16. So the cyclicity is of 5. Cyclicity is of 5. So this 506 is 5q plus 1 type of number, which means your last digit is going to be 16. So my last digit is going to be 16. In this case, 16 times 2 is 32. This is how you do it. This is how you do it. Did you get it or not? Do you want me to give one more problem of it? If you want me to give me one more problem of it, let me know. See, like Sonal Agarwal, this is something which is particular to 76, but you can get anything. You can get anything. You should be able to solve a general problem. In the next question, which I am going to give, I am not going to give you any even number. I am going to give you an odd number. Right? So let us see if you can solve it. Right? So please write this. This is a general method. It is applicable in all the problems. How did you add 4? See, like I have not added 4 to the powers. I have manually calculated it. 16 to the power 1 is 16. 16 to the power 2 is 256. The last 2 digit is 56. 16 to the power 3 is 4096. Like, see, like I told you, I remember the powers of, like I know 16 powers of 2. So 16 to the power 3 is 2 to the power 12, which is equal to 4096. Right? So last 2 digits are 96. And then I got the pattern 16, 56, 96, 36, 76, 16. Right? Then I got the pattern. Right? First few calculations are to be done and then you have to observe the pattern. Got it? Let's do it. Let's do it, guys. Let's do it. Okay. In which year you were born? In which year you were born? Any one of you. Any one of you. In which year you were born? Please tell me. 2010. Good. I have got 4 people born in 2010. So, find last 2 digits of 3 to the power 2010. Fair point, right? Simple. Go for it. Go for it. Tell me, guys. Tell me, guys. Tell me. I'm not being able to see the video comment somehow. Let me open it here. I'm not being able to see your comments for some reason. Olympiad corner, Olympiad. This is the close. Let me mute it. Go for it. 49 is what you are saying. 49 is what you are saying. 49 is what you are saying. Let's see. Seema Gupta says 49. Ojas says 29. Last digit is going to be. See, like there is no rocket science in it. Now again, the problem here is the unit digit cyclicity is 4. I am going to negate it. Let me create 1, because if you let me do it. Solution. Can I write it as 3 to the power 2 times 3 to the power 2008? This is divisible by 4. 3 to the power 2 equals 3 to the power 4 to the power 502. 3 to the power 2, 81 to the power 502. Let's just write it. Right? Right? So see, like, just for the sake of it, let's assume that last two digits are 21. Let's just assume it. Then you multiply it by 9 and you will get 189. So these two will be the last digits. So all I have to do is to find last 2 digits of 81 to the power 502. Right? I hope we are on the same page. Here. Right? I hope we are on the same page. Now, but this is not going to be very easy. 81 to the power 1 is 81. 81 square is 6561. Interesting. Let's see if I get 41 now, because 81, 61. If I get 41, I am sorted. All I have to do, multiply 61 with 81. Right? 61 with 81. Right? So you know, do you know the trick? Do you know this trick? 140 and then 48. Do you know this trick? Do you know it or not? Like this type of Vedic mathematics, right? So the last digits are 41. Right? So indeed, 81 to the power 3 is 41. I got my pattern. I got my pattern. Right? Again, the cyclicity here is of 5. The cyclicity here is of 5. So this is 502. It is equivalent to, when I divide the power by 5, I get 81 to the power 2, which is 9 times 81 square is 61. 61 times 9 is nothing but 549. So my last two digits are 49. Some of you got it correct. Can you teach that Vedic trick? See, like it is very simple. Very simple, guys. So if you take any two-digit number, 86 times, let's see, 43. So first you multiply these two, 18. Then you multiply in cross, 24 plus 24. You get 48, right? So write 4, 8. You have to shift. 8 times 4, 32. This is your answer, 3698. This is how we do it, right? Sir, does IOQM Ramanujan course will also help in? See guys, that is why I gave you the video of AIR3, right? He was in my IOQM course only. He secured All India rank 3. He got 100 out of 100 in JEE main mathematics examination. Do you need any more validation? Just give me an honest answer. Do you need any more validation? We have got All India rank 1 in ISI, which is the toughest examination of mathematics. Do you need any more validation? And all these boys who have performed well at the national level, they were very sincere in IUQM. They were not very intelligent. They were very sincere. They completed the course, and that is how you understand. Like that is why I upload these videos to let you know, right? I hope I'm making sense, guys. I hope I'm making sense to you all, right? Perfect. Right? So last digits, this is good. This is all good, right? Now we are going to do some alphanumeric problems. Alphanumeric problems, which is also related to problems, right? So, like the one which I posted in the morning, right? Let A, B, C, D are digits. Digits. Find A plus B plus C plus D. Find A plus B plus C plus D if AB times CB equals DDD. Right? Please go through it and find. Let me know if you get it. Let me know if you get it. Tell me guys, tell me guys, tell me. Perfect. Perfecto. When will this topic be covered in recorded Hindi course? I think in next week. Next week. Like the week from 23rd of December to 28th of December. Right? Now see, like the silver lining here is, this is DDD. Can I write it as D times 111? All numbers of the type DDD can be written as D times this. And if I factorize it, I get, this is my beautiful number. So one 2-digit number is 37 for sure. Right? And since this is B, this is also B, I get 7 here. 7 times 7 is 9. And since all the digits are same, I get this as my answer. Now see, this is 999. So just write 999 by 37. 27. So this is your sum. So 3 plus B plus C plus D, you get 21. Right? 21 is the correct answer. Only Sonal is solving. And that too I am 100% sure. This is a boy from mother's account. Am I correct, Sonal Agarwal? Am I correct? What is your name? Is it from QOTD? See, like this QOTD, the QOTD which I gave today, it was related to this lecture, right? In fact, I should link it. Let me link it. I'll do it. I think I can put this. Just a second. I'll do it. Let's do one more problem, and I'll link this to. I'll link this lecture to QOTD, which I gave today. Question, right? Find largest possible prime divisor of number AB. 6-digit number. It is a 6-digit number. Let's do it, guys. Let's do it. I invite you to do it. This is a very nice problem. It's a very nice problem. It was asked in KVPY. Guys. Apart from Ramanujan batch, new batch will come for IOQM? Yes, see, like the Ramanujan will keep on coming. We have already started Ramanujan 3.0. The response has been super amazing. So if you want to join, you can join, and you can then you can go to the next batch also. It is not a problem. Hello, Seema Gupta. Vaibhav Agarwal. 10101 is not a prime number. Come on, yaar. 10101 is not a prime number. See, like, largest possible prime divisor of number. Solution. Come on, yaar. What are you doing? So, and majority of the learners make this mistake, by the way. Right? This is PJ exclusive. This is PJ exclusive. Majority of you will make this mistake. And that is how you learn. It is better to make mistakes in PJ sir's class rather than in the main examination, that is IOQM. And by the way, I am thrilled to tell you that we have got 157 selections in RMO. Our highest score is 102 out of 102. Then we have got 86, then we have got 83. These are our top 3 scores, 102, 86 and 83. So we have been doing some amazing work in Mathematics Olympiad, and I hope that we get medal this time. 3367 is not a prime number. It's your... So see, like, it is AB times 10101. Now let's factorize it. 10101 is 3 times. How do you solve it? 10101. 3 times 3, 3, 6, 7. Try it with 7 also. It is divisible by 7. 8. Oh, not 8. 4. 81. It is divisible by 13 also. 3, 7. So it is 3 times, 7 times, 13 times, 37. You have to check it. Right? You have to check it. Right? So, every number, please note it down, every number, if not prime, will be divisible by one of the prime, which is less than square root of the number. This is very important note. So if I have to check if if I have to check that 3367 is prime number or not. If it is not a prime number, it will be divisible by one of the prime number which is less than square root of it. So what is approximate square root? Approximate square root is 60. So it will be divisible by one of the prime number which is less than 60. Right? Like I told you, majority of you will make this mistake. Majority of the learners give 37 as the answer, but you can also fix this, right? I can fix it as 97, isn't it? I can fix it as 97. So 97 is the answer. Majority of the learners make this silly mistake. They give 37 is the answer because, see, like, what they think. We have factorized it with so much effort and we have got 37. 37 is such a nice number. In fact, 37 is my second favorite number. Why 37 is my second favorite number? See, its reverse is 73. Minus 37 is 36. This is prime number, this is prime number, this is prime number, this is prime number. Their difference is perfect square. And perfect square of 6, which is the least perfect number. And that is why this is a perfect number. And this is why I love 3773. So 97 is the answer. 97 is the answer. 97 is the answer. No. See, like, find largest possible. Right? Possible. It is written possible. Prime divisor of number. And I have not written every number. Every number of the type. I have not written this. Every number of the. I have asked you possible. So you made it possible. 979797 is the number. Right? Got my point? Got my point? Perfect. Let's move on to the next one. Let's move on to the next one. Yes. Yes, 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 yes. 3, 3, 3, 3 is divisible by 383. It is given. Find last three digits of 3, 3, 3, 3 divided by 383. Let's do it. Let's do it. This is the last problem and the most interesting one. There was a bit of lag, but you don't have to worry. I have not told anything in that period. I've just written that this is the most interesting problem and this is the last problem of this lecture. This is the last problem of this lecture. Please try it. Please try it, guys. Sir, is it necessary to do any other thing after solving your book for IOQM? See, like at the current level of IOQM, which was asked in 2024, my book is more than sufficient. Many of the learners have secured more than 50 marks after completing my book. But yes, completing my book is absolutely necessary. You have to do each and every question of it. Yash Pillai, 383. No. Now let's see how multiplication works. Let's see how multiplication works. Can I say that there is a number which when multiplied by 383 gives me 33333, right? Just a second. Let me correct it. Let's see how multiplication works. It will give me 333333333. Am I making sense, guys? Please tell me if I'm making sense or not. Am I making sense? And how do I multiply? 3 times. See, like this is 3. So 3 times 1 is 3. So I have to get 1 here. If I have 1 here, 8 times 1 is 8. 8 times 1 is 8. Now, what do I have here to get 3 here? Absolutely, 5. How do I get 5 here? 3 5s are 15. Carry over 1. Carry over 1. Right? So, let's see. 3 times 1 is 3. Now, 8 times 5 is 40. Carry over 4. 3 times something. 3 times something has to be. Now, see here. You have to get 9 here. You have to get 9 here. Because 3, 5 plus 8 is 13. Carry over 1. You have to get 9 here. But you already had 3 times 1 is 3. 3 times 5 is 15. Carry over 1. So, if you get 6 here, 3 times 6 is 18. 18 plus 1 is 9. So, your last 3 digits are 651. Do you get it? This is 5 marker. 5 marker. 5 marker IOQM. This is not a simple problem. It requires a great deal of understanding of numbers. Do you get it? This is how you multiply. Did you ever imagine that multiplication can be such tricky thing to understand? Right? All I have done is multiplication, nothing else. Right? How can I get SEHSS book? Guys, go to Amazon, buy it. The book name is IOQM Mathematics. Pathfinder, see, like it used to be the name of my book, but now it is renamed as IOQM Mathematics. No. I can give one GBQ, one goodbye question. Let me give you one goodbye question. See, like you need discount in everything, yaar. You need discount in book, you need discount in everything. Right? So, like, see, like if you go for lower pricing, you get lesser quality. You need to understand this thing. Right? And we are doing so many things for free anyway. Like, I prepared for my JEE by giving 45,000 rupees for 1 year. I gave 90,000 rupees for 2 years. Back in 2006 to 2008. At that point of time, the value of 90,000 rupees is roughly equivalent to 9 lakh this time. And I do not regret it because I went to the best coaching and from like of that time. I studied from the best mentors. So you have to think, can you compromise on the quality? Can you compromise? Because this is your only chance. You are not going to be in 10th forever. You can give IOQM in 10th class once. You can give IOQM in class 9th once. There's no repeat here. If you fail in half yearly, if you do not do well in half yearly, you can improve in like annual examination. But IOQM, if you mess up with your IOQM examination, you get to do it in the next year. So you need to value time also. Right? Right. Now, GBQ is goodbye question. Goodbye question. Let me give you a goodbye question. Right? There are 6 prime divisors, exactly 6 prime divisors of number AB. Find number of such 6-digit numbers. Right? You have to find and just write it in comment section. Write in comment section. Write in comment section. Write in comment section. So today is a very interesting lecture because this lecture will form the basics of number system. In fact, number theory. What we have done till now, we have done basic number system which is available in NCERT also. And we have taken it to another level so that all of us can have a very good base. Now that our base is ready, we have done like factors, in fact we have done cyclicity and some divisibility rules, basic things we have done. Now I am going to start with Euclid division lemma and basics of congruence. So see, what is Euclid division lemma? Euclid division lemma is a very fancy name, right? We call it Euclid division lemma. It's a very fancy name but has a very simple statement. Okay. So the simple statement is for a given divisor and dividend we have unique quotient and remainder provided that remainder is greater than 0 and less than divisor, right? So basically what does this mean? That let's take dividend is equal to 42, divisor as let's take 5. Then 42 can be represented using a unique combination of quotient, that is 8, and remainder. And what you have to make sure, remainder is always between 0 and n minus 1, where n is divisor. So my remainder is greater than equal to 0, less than equal to n minus 1, right? N is divisor, and obviously whatever I am defining is for natural numbers, right? Whatever I am designing is for natural numbers. Whenever the remainder is asked, remainder, see, like, we will not overcomplicate it. You have known the meaning of remainder from your childhood. Somebody will say that, sir, our childhood is still going on, but since you are studying for examination, complicated examination like IOQM, I think you have decided to take challenges in life, and only a non-child can take such serious challenges. So you have already grown up, and that is why it is safe to assume that you know that remainders are between 0 to n minus 1. Am I making sense, guys? Am I making sense? Am I making sense? Am I making sense, guys? Perfect. Perfect. So see, this is the statement, and some would argue that sir, like, and based on Euclid division lemma, we define all the things, right? Please write UDAN so that I can move to the next slide. Based on Euclid division lemma, we'll define many things. Based on Euclid division lemma, we will define many things. Please write UDAN. Perfect. Right? So, some application of EDL. It sounds like idiot, but it is not idiot. It's a very important concept. I don't know why NCERT removed it. It's a very, very important concept, especially for JEE aspirants. Some application of EDL. Any number which leaves R as remainder upon division by D, or let's say N, can be represented in the form NQ plus R. For example, if 7 is divisor, then 5, 12, 19, 26 are of the form 7q plus 5. So sometimes we are required to prove some things. For example, if I have to prove something for odd numbers, then I cannot verify it for every single odd numbers. There are infinite odd numbers, right? 1, 3, 5, 7. There are infinite odd numbers. So if somehow I have a representation for odd numbers, what is a representation for odd numbers? 2k plus 1. every odd number can be represented in the form of 2k plus 1. If I take this general value and if I prove something for that, then I do not have to prove for every single odd number because I have proved it for the general form. And that is why having this general form helps. That is why having this general form helps. Do you get it? Do you get it? Do you get it? Are you able to get it, guys? This is a very important thing, in fact. Right? Perfect. Right? So, if you have understood it, please give me, if 11 is divisor, what is the general form? What is the general form of 4, 26, 50, 48, sorry, 70, etc. What is the general form? See, like, general form will always be dependent on divisor. What is the divisor that you are taking? What is the divisor that you are taking? It will be dependent on that. 4, 26, 48, 70, etc. People are saying 11q plus 4. What do you mean by 11q plus 4? All these numbers upon division by 11 leaves 4 as remainder. All these numbers upon division by 11 leaves 4 as remainder. Getting my point? Getting my point? Damn. So, like, Yash gave the answer so fast that somebody was writing, Yash, did you predicted it? Obviously, it was not predicting. It was not prediction. He knows the basics, so he was able to answer very fast. Getting my point? Right? Perfect. So, another point. Any number can have multiple ideal representation based on the divisor. Right? Based on divisor, it can have multiple representation. For example, 42 is 5q plus 2, 4q plus 2. See, like, it is leaving the same remainder upon division by 5 upon division by 2. But it is of the type 6q, it is of the type 7q, it is of the type 9q plus 6. Right? 10q plus 2, 11q plus 9, etc. Getting my point? It has different representation if you change the remainder. With some remainders, it is giving the same remainder. For example, for 5, for 4, for 10, it is giving the same remainder. But largely, it gives different remainders. Right? And then one very simple point, if the remainder is 0, then that particular number is then the particular divisor is factor of the number. Right? For example, 6 and 7 are factors, or you can call them divisors of 42. You can see it. The remainder is 0. Right? This is a C line. What I'm trying to do here is, you know the definition of factor. You know what is a divisor. I'm simply relating the concept of Euclid division lemma with the known concepts which you know already. Okay? And like we discussed it in divisibility also, what is the meaning of divisor, what is the meaning of factor, right? So what we are trying to do here is to relate each and every known thing with Euclid division lemma. Okay, please note it down and write UDAN. Sir, I got your book pre-RMO, can I read? It depends on your English skills. It is written in English. If you can read it, you can read it. Right, right, guys. Perfect. Perfect. Right? This is one important concept. Now, how it is used? This is the question. Prove that all perfect squares are of the type first 4k plus 1, 5k plus 1, 5k plus 2. Right? Please do it. Please do it, guys. Please do it. Please do these both these questions, right? Now you are proving, see, like your proving has to be backed. So what is the ideal? See, like this is something which you will require for RMO also. If you remember, for this year's RMO, we did a question using Euclid division lemma. So for first, what you are going to write? Let the number be 2k, 2q or 2q plus 1. Then you take case 1. Now again, you see, like this is a very, very common question among learners. Sir, how do you design, how do you select the divisor, right? Because the divisor is your choice, right? Divisor is your choice. So it is typically dependent on the question. So here 4k, 4. So what is the prime divisor of 4? 2. In this case, we'll take the divisor to be 5. So let's solve the first one. Now, every natural number can be represented as 2q or 2q plus 1, right? Right? Any number you can think of, either it is even or it is odd. Am I making sense? This is perfect square of a natural number. Let's assume that the question which is being asked is for squares, perfect square. So let's write 1, 4, 9, 16, 25, 36. Now, a square of even number will be divisible by 4. So this is sorted. This is very easy to see. But it is a very interesting thing that all odd numbers leave 1 as remainder upon division by 4. Now, it is not something which is observational. It has a proof also. So let's take n is equal to 2q. If you square it, you get 4 times q square, which implies 4 divides n square. So this is hence proof for first case. Now case 2, simply take n is equal to 2q plus 1. Again do the square. If you do the square, you get 4q square plus 4q plus 1. Now see, q was an integer. Obviously, since it is a quotient, q square plus q will be an integer again. Let's take this as an like whole number, and then 1 is the remainder. So this proves my claim. Since I have proved for odd numbers, since I have proved for even numbers, it is complete, because a number can either be even or odd, simply, right? This is 5k plus 4. My mistake. This was 5k plus 4. It was meant to be 5k plus 4. My mistake. Which chapter you start after geometry in IOQM Hindi recorded course? See, like guys, what I'm trying to do in recorded course is that I'm trying to complete the basics thing. So after this, I will be covering set theory, right? 2 lectures of set, 1 lecture of wavy curve, few lectures of then maybe modulus and something, which are basics, and then we will pause the course because of boards, because of multiple things. You have school exams as well. We'll resume the course on 15th of March. From 15th of March, we will start with algebra, proper IOQM algebra. Then we will go with number theory. Then we'll go with geometry, proper IOQM geometry, proper IOQM number theory, and then we'll go with PNC. Getting my point? This is the broad plan. Now let's go for the second one, right? Let's go for the second one. Numbers can be of the form 5q plus 1, 5q plus 2, 5q plus 3, or 5q plus 4. See, if your divisor is d, then there are d possibilities of remainder, 0, 1, 2, 3 and so on till d minus 1. So if 5 is my divisor, I will have 5 possibilities, right? Again, A, let's take n to be 5q. Very simple. N square is 25q square, which essentially means 5 divides n, right? Or n is of the type 5k, which was asked. B, n is equal to 5q plus 1. N square is 25q square plus 10q plus 1. Now you can see 5, it is divisible by 5. So I can write n equals 5k plus 1. This whole number is divisible by 5. So I can represent it as 5k, 1 is the remainder. Second, n equals 5q plus 2. N square is equal to 25q square plus 20q plus 4, which essentially means that n is 5k plus 4. Similarly, if I have n equals 5q plus 3, then my n will be 5k plus 4, and in the last case I will get n equal to 5k plus 1. But see, like, this is the proof, this is the formal proof. A question might arise in your mind that, sir, if at all this divisor is bigger, maybe 7, maybe 9, so then will we be taking 7, 9 cases? No, we won't be. That is why a very beautiful representation was invented, known as congruence representation. Right? You are getting the need of it, right? This proof is very lengthy. Right? We'll do it later. right? Nice. Perfect. So I am going to prove second point with a very different representation. I am going to write n congruent to 0, 1, 2, minus 1, minus 2, mod 5. What do I mean by this? What do I mean by this? In fact, I will not write like this. I am going to write it as plus minus r. This means that n is of the type 5q plus minus r. Now I am not saying that r is remainder. I am not saying r is remainder. What I am trying to simply say is that, see, like, let's take the example of 9. Can I write it as 5 times 2 minus 1? I am not saying 2 is quotient. I am not saying minus 1 is remainder. I am not saying minus 1 is remainder. Please listen to this very, very carefully. I am not saying 2 is quotient. I am not saying minus 1 is remainder. Remainder is always non-negative. Remainder is always non-negative. You need to understand this thing. But I can certainly say that 9 can be represented as 5q minus 1, which means 5q minus 1 is equivalent to 5k plus 4, right? Because 9 is also of the type 5k plus 4. So I am saying that every number can be represented as this or this or this. See, this is precisely the point. I have effectively reduced the cases by half. I have effectively reduced the cases by half. Am I making sense? Am I making sense? Please tell me. K and Q are always variables, guys. See, like, you don't have to worry about Q and K. Q and K will take their value. All you need to understand is that Q and K are integers. Why I am saying this? Just write 9 as this. Then your Q will come out to be 2. Write it as this. Your K will come out to be 1. Getting my point? This is the whole idea. This is the whole idea. Okay. Am I making sense, guys? Am I making sense? Am I making sense? Perfect. This is very good. Right? So, now what happens is that, see, like, we are going to write a very simple thing. If n is congruent to r mod d, it implies n square is congruent to r square mod d. What does this mean? What does this mean? That to find the remainder of n square upon division by d, we simply have to square the remainder. There is a very simple proof of it. N is dq plus r. You square it. N square equals d square q square plus 2rqd plus r square. Now can you see that this number is divisible by d? So I can write it as dq1. q1 is another integer plus r square. So this means that n square is congruent to r square. N square is congruent to r square. Can I say this? Can I say this? Can I say this? Please verify. Please verify. Can I say this? This is the proof of it. This is the proof of this statement. A very important statement, and we are going to use it. We are going to use it. The proof is not complete yet. I have introduced something. I have proved that. So typically in solutions of RMO, INMO, if you introduce something, for example, I have introduced this thing, then you have to prove it. This is called lemma. This is called lemma. L-E-M-M-A. Right? Lemma is a statement which is made to prove something big. Right? This is lemma. Perfect. Good. So can you write UDAN so that I can move forward? You can simply write UDAN so that I can move forward. Perfect. Perfect. So these were my cases, right? N is congruent to plus minus 1, mod 5, N congruent to plus minus 2, mod 5, right? Can you see this? Now I am going to simply square it. Plus minus 1 square is 1. Is it very eco-friendly? Why do I call it eco-friendly? It will consume less of your page. It will consume less of your ink. That is how. This is one way of mathematicians to give back to society by saving trees. It is an eco-friendly thing, right? It is a very eco-friendly concept. Right? Am I making sense? Please say if I am making sense. So we remove the negative. See, like upon squaring, negativity is removed. And that is the thing. You should always have belief in you. Like you call it, right? We call it that having self-belief removes any negativity. How? You multiply yourself with yourself, right? Like believing in like oneself. Like if I am believing in myself, then I am multiplying myself with my inner soul. So that is how perfect squares are always non-negative, right? Sir, I am not a brilliant student in mathematics, but I am passionate and love mathematics. Can you teach the path of IOQM daily routine, or what will I do? Please replace it. I have given you the roadmap. You just have to follow my Telegram channel, and I'll be giving the daily targets on it. Right? Perfect. I think this is done. This is done. But I think we should explore about the congruence a bit more. Right? Yes. Represent in, it is called represent in congruence modulo. It is called congruence modulo, right? Congruence modulo. right? I am writing D as the dividend and small d as divisor. So for example, in this case, in fact, let's write a table. Let's write a table, right? So this is D, this is small d, this is representation. For example, if D is dividend, this is 4. So I'll write it as 45 congruent to 1 mod 4, right? So what do I do with it? What do I do with it? Sir, quota teachers joining an academy. Yes. Yes, we are hiring. We are doing well in quota. And so we are expanding our footprints. Right? So now this is a very interesting point. First of all, 82 can be written as 1 mod 9, okay. But it can, this is correct, but this is also correct. 82 is congruent to 10 mod 9. This is the second representation. This is the second representation. What does this second representation means? 82 and 10 leaves same remainder upon division by 9. Upon division by 9. Right? Upon division by 9. Upon division by 9. Yes, you can get it, Ayush Pandey. Or I can write it as 82 congruent to minus 8 mod 9. That is also okay. In modulus, negative integers are also allowed. Negative integers are also allowed. This is the fun part. Why should positive integers have all the fun? No, negative integers can also have fun, right? 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 Am I making sense? Am I making sense? Can we manipulate to get another divisor? No. That is the benchmark rule. Otherwise, you can do anything. But anything is not allowed. Some things are allowed, keeping the divisor same. See, this is very important. I am keeping the divisor same. Otherwise, 82 will have an entirely different thing. See, like if you change the divisor to 11, 82 becomes 11q plus 5. And it makes absolutely no sense. See, like apples can be compared with apples. What I am trying to say here is that if I have taken mod 9, 1 is congruent to 10, is congruent to minus 8. These three have the same meaning. That is what I am trying to say. Right? Perfect. Perfect. So, now, prove that all perfect cubes are of the type 9 cube plus 1 or 9 cube plus 8. Let's see if you are able to do it. Yes. Yash knows it all. That is why he is Yash. Yash means glory. He is a glorified kid. What he is saying, sir, take 9 equals 3q. This gives me n cube equals 27q cube, or it is 9k, right? Now, if you take n congruent to 1, right? In fact, let's not take congruent. So this was an NCERT question, and obviously modulo is not involved in NCERT. So we have to give the proof which can be written in NCERT. So it is largely based on algebraic identities. A plus b whole cube is a cube plus b cube, or what should I write, 27q square plus 9q plus 1. So if you carefully see, it is divisible by 9. So this becomes 9k plus 1. Last but not the least, n is 3 cube plus 2. If you cube it, you will get 9k plus 8. Right? 9k plus 8. But what if you were to take, what if you were to do this in terms of congruence? Now this is the challenge with congruence. You will have to take 9 as the divisor, right? You have to take 9 as the divisor. As midway, you cannot change the divisor. So n congruent to 0 mod 9, n congruent to 1 mod 9, and you cannot take plus minus because cube of negative is negative, cube of positive is positive. So I'm not going to write it like this. I'm not going to write it. It will be very lengthy. I'm simply going to do, I'm going to make a table. This is n, this is r, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, right? I think it is visible. Yes. What is r cube? Mod 9. 0, 1, 8. 0. What is 3 cube? 27. 27 is 0 mod 9. 4 cube is 64. 64 is 1 mod 9. 5 is 125. 125 is 8. So this is going to be, so you can see here remainders are 0, 1 and 8 respectively. This is the table which I am going to make. Please write it down. Please write it down, guys. I hope you are understanding these concepts. I hope you are understanding these concepts. Right? Did you not teach the inequalities in IOQM? I believe I have done that. I believe I have done that. right? Perfect. Perfect. Should we do one more problem? Should we do one more problem? Solve for A, B, C belongs to natural number. A square plus B square equals 8C plus 3. Solve it. This was RMO problem. This was RMO problem. This was RMO problem. It has also come in NTSC stage 2. NTSC, it was a very well known examination, but now it is no more. Have you done it? Have you done it? Yes. So the answer is no solution, but this has to be proved. If the answer is no solution, you cannot simply say. You have to prove it. So A square is 4k or 4k plus 1. B square is 4l or 4l plus 1. Right? If you add them, if you see, A square plus B square can be congruent to 0, 1 or 2 mod 4. It cannot be 3 mod 4. It cannot be 3 mod 4. Right? And this number 8c plus 3 is congruent to 3 mod 4, which is a clear contradiction. Hence, no solution. Hence, no solution. Right? Hence, no solution. See, like, we are not solving the Delhi paper because we did not get any. Nobody sent the paper to us. If we got the paper, we would have solved it. Right? Just send to me on my Telegram. This is my Telegram. @ Prashant 42 Jain. Prashant 42 Jain. Right? Perfect. Let's move on to the next one. Let's move on to the next one. Now we are going to study the concept of HCF and LCM using EDL. Right? Right? What is highest common factor? Highest common factor, it has a very simple definition. HCF of A comma B is represented as simply A comma B is highest divisor which divides A and B. What does this mean? This implies if H is HCF of A and B, then A upon H, B upon H should be equal to 1. This means that HCF of A by H and B by H should be 1. Right? This is the definition of HCF. This is the definition of HCF. This is the definition of HCF. The rock. See, like I remember a student named Sanil, but I lost track of you. Where are you now? Where are you now? JEE 2024. IIT BHU, congratulations, man. You got into IIT. Perfect. See, if H is HCF. Now, let me give you an example. You all know that HCF of 42 and 78 is 6. Right? So, just simply divide by 6. Right? These two numbers should be co-prime. Are they co-prime? Yes, they are co-prime. Are they co-prime? Yes, they are co-prime. Getting my point? So, we simply write A equals Hindustan Petroleum, B equals headquarters. This implies PQ. This is the official, formal statement. This is known as HCF. This is known as HCF. This is known as HCF. This is actually the next lecture also, HCF and LCM. But we are going to clearly write. And P and Q should be natural number. This is a very important point. P and Q have to be natural number. Sir, why are you taking lectures in English? See, like I have given everything to my Hindi audience, right? And I came to know that I have some fans who like study from me in English. So I have decided to make lectures in English. Correct? Perfect. Right? Now, finding HCF using, this is a very important thing, EDL. This is called EDA, Euclid division algorithm. This is called Euclid division algorithm. Right? Now, if you remember, we used to calculate HCF in this manner. So, 42 is written here, 78 is written here. You write 42 here, 36. Then you take this here. And once you have 0, this becomes your HCF. So the way to do it is, you start with larger of the two numbers. Let's assume that I have to find divisor of HCF of 78 and 42. So this becomes 42 times 1 plus 36. Then in the next step, you make this as your dividend and your remainder as divisor. Again, in next step, you make this as your dividend, remainder as your divisor. Once you have 0 as your remainder, this becomes your HCF. Right? You have always known this step. This is the way to write it. This is called Euclid division algorithm. Euclid division algorithm. Euclid division algorithm is used to find the HCF of two numbers. Obviously, see, like, this is not the effective way to do it. We can write it using this type of table, right? In your younger days, you must have found it like this, right? HCF and LCM, finding HCF and LCM using this table, I don't remember it. But now you are a big guy. You have to prove these things in RMO. And in RMO, these type of things work. Perfect. Got it? This is what I like. This is what I like. This is what I like. Perfect. Now, let's do one thing. This is Euclid division algorithm. Yes. Let AB belongs to two natural numbers. Let AB be two natural numbers such that A plus B equals 90. If AB equals 6, find number of unordered A comma B. You have to find number of unordered A comma B. Now, what do I mean by unordered A comma B? So 78 and 12 is one solution. So 12 and 78 cannot be another solution, right? I just want unordered pairs, which means 78 comma 12, value of A equals 78, value of B equals 12. Value of A equals 12, value of B equals 78 should be considered same. They are not distinct. right? How many? 9 unordered pairs. Let's see. Let's see if what Yash is saying is correct. I think you all should try it. This is the last question which we are going to do. A plus B equals 90. Now we are not going to solve it. Simply not solving like this because it has 89 solutions, right? You remember we did a lecture on indeterminate equations. We solved it. It has 89 solutions, right? But all the 89 solutions are not acceptable because additionally we require that HCF should be 6. So A is 6P, B is 6Q, and PQ should be 1. I substitute it here. P plus Q times 6 equals 90. My P plus Q becomes 15. Right? Right? Now, 1 14, 2 12, 3 10, 3 11, 4 10, 5 9, 6 8, 7, just a second, 1 11, 2 13, 3 12, 4 11, my mistake, 5 10, 6 9, 7 8. Since I am not looking for unordered solutions, since I am looking for unordered pairs, I do not have to go further than this. So 1 2 3 4 5 6 7. But there's a problem. If I take this as my this can be taken, in fact, if I take this as my solution, what does this mean? My P is 3, Q is 12. P and Q, the HCF of P and Q has to be 1, no? So this solution is rejected. This is accepted, this is accepted, this is accepted, this is rejected, this is rejected, this is accepted. So I have 1 2 3 4, only 4 solutions. Devil lies in the details. You have to focus on each and every detail. Each and every detail, guys. It should be 4. Do you all get it? Let me start. HCF and LCM. We will start with a very simple thing. Let's find HCF of 24 and 36 and the LCM. This is the sign for LCM. This is the sign for HCF. So small brackets are used for HCF. This like big brackets are used for LCM. If you can find the LCM and HCF of these two numbers. So Yash is saying that the LCM, sir, is 12 here. Okay. HCF is 12, sorry. And LCM here is 48. Is it not 48? 72. 72. Right? Now, if you see properly, the product of these two numbers is actually equal to the product of HCF and LCM. This is a very important property. What I am trying to say is HCF of A and B times LCM of A and B equals product of these two numbers. It has a very simple proof, and I would advise you to grasp everything after proving it. And if you are not being able to prove it, see the proof first and then try to do it yourself. So I am going to take the case. Let A equals H times P, B equals H times Q. Right? Because of the premise that H, since it is an HCF, it divides A as well as it divides B. And this is the highest number to do that. That is why it is known as highest common factor. Right? So, if we are saying this, we are saying that PQ, the HCF of PQ is 1. That is what we said here last time, right? Now, what is the LCM? LCM is going to be, see, let's take the common factors and then we take the co-prime factors. So LCM is going to be this. So if you do the product of HCF LCM, you are getting H times HPQ. And now if you simply arrange these numbers, HP times HQ, this is the product that you get, So HL equals AB. This is a very simple proof. Now every proof is a thought process in itself. I keep on saying this thing, that every proof is a thought process in itself. Why this is a thought process? In all the problems related to HCF and LCM, this thought process that we have to assume one number as HP, one number is a HQ, and then the LCM becomes HPQ. These assumptions, these starting steps lay the foundation of solving very difficult problems. So if you can write them, it would be amazing. Please write it down and write UDAN so that we can proceed. Write UDAN so that we can proceed. Got it? Perfect. Let's do one problem here. Let's do one problem here. Let A and B be two numbers such that their HCF is 24 and LCM is 60. Find number of ordered A comma B. How many possibilities of A and B? Two one six five three three. 216533. Right? Let's try to see it. Sir, should solving your book if we follow your Hindi course? Yes. My all courses are aligned with my book. Obviously, I have written it. Perfect. Very good, Yash. Yash has observed one thing here. Yash is saying, sir, this question is absurd because your HCF should divide LCM, which is not happening here. 24 cannot divide 60, right? So in this case, no solution. Very good. Same thought process, Yash. Are you following the same thought process? Correct. Now let's do the second part of it. Let's see if HCF is 24 and LCM is let's do 480. Right? Let's do this. HCF is 24, LCM is 480. The second part of it. It is good that you have been able to observe the first part. Sir, I want to pursue JEE as a goal in future. Should I try for NSCJS or IOQM? Go for IOQM. Every JEE aspirant who is very, very clear that sir, JEE is the ultimate goal, for them IOQM is absolutely must. Literally, it is absolutely must. 4 ordered pair. Let's see. Now, again, my thought process is very simple. Sir, A equals HP, which is 24P, and B equals 24Q. And I have to make sure that PQ equals HCF of P and Q is 1. We have to make sure of it. Now, I am going to follow the property that HCF into LCM is equal to the product of two numbers. Right? So 24 gets cancelled with 24, 24 gets cancelled with this. P times Q is 20. Right? Now, product of two numbers is 20. So let me write P here, Q here, 120. And since I am asked ordered pair, I will have to write 20 and 1 as well. 210. I cannot write this because I have to take P and Q as ordered pair. So this is not allowed. Right? So I am simply not writing anything here. 4, 5, 5, 4. 2 more. I think that is it. Because 20 has only 6 divisors. Yes, that is it. So in total, 4 ordered pairs. 4 ordered pairs. Right? This is the meaning of ordered pairs. Where ordering matters. Right? For example, in this case, your one number is 24, another number is 480. This is one pair. So 480 and 24 is another pair. 2. Simply here, 24 times 4 is 96. This is another pair. And this is the fourth one. Right? 2, 10. We ignore 2, 10 because HCF of 2, 10 is not 1. It is 2. Right? You cannot take two numbers which are not co-prime. You cannot take it. Because, see, simply just write it down. The two numbers are 48 and 240. Now their HCF is not 24, their HCF is 48. But it is given in the question that the HCF is 24. Am I making sense, guys? Right? Perfect. Let's move on. Let's move on, guys. I think you have noted it down. I'm going to see, like, I'm going to reply to the queries which are general after giving a question, right? After giving a question. Perfect. Right? Find all possible values of CF of 2n and 98 minus 3n, where n belongs to natural number. So these are the two numbers. You have to find all possible values of HCF, right? Meanwhile, let me answer some question. Amal KK is asking, sir, I bought the book Algebra for Beginners. If possible, please start a series of that book. No, not possible for me. Guys, it is simply not possible for me to teach each and everything. Let alone Algebra for Beginners is a very simple book. You have to, first of all, just get the solutions of that book. One very good way to solve any book is to, first of all, start with a book which has solutions. And then try to study for the lectures and then do it. Because see, like, I have started IOQM English course after much deliberation and I am going to finish it for sure because it is going to help a lot of students in near future, because there is no course which is available in English, right? But other than all the courses, other than this course, all the courses, like, learners keep on coming to me, sir, please start this series, please start that series, and then they do not see it after 2 or 3 lectures. So that is the problem which lies in YouTube studies. The seriousness of learners is very limited, right? For example, I can say this thing for sure that only, like, Yash is the only student, Yash Pillai, who is seeing all the lectures live.
No other student. Like I do not remember any student. There might be some students who are attending it in recorded format, but he is the only one who is attempting it live. While around like 100, more than 100 learners promised me that sir, if you get us the live lecture, I will attend it live. So these are, sir, see, like these are simply lies for me. Like I have been teaching for YouTube on YouTube for last 6 years. Learners do not keep their promise and they expect us to keep our promise. This is very bad. That is what I think. Then Arjun is saying, sir, but the problem I am facing is that I am class 8th going to 9th, some chapter like trigonometry. See, like you are a learner of class 8th. See, like there's a progression of study. If you are in class 8, first of all finish NCERT class 8, NCERT class 9th, NCERT class 10th. Then do the foundation books like Envision series, I have told you. And then go on to the JEE chapters. If you try to skip, then you'll not be able to understand it. There's a proper progression. You do not jump the ships. Right? Now, can you give me this answer? So, there is a property which will help you. There is a property which will help you here. If H equals P comma Q, then H divides A times P plus B times Q. AB belongs to integer. Now, what is it saying? This is a very complicated looking statement. This is saying if H is the HCF of P and Q, then H will divide any addition of P and Q. Any addition of P and Q. Very simple proof. P1 is HP, is P. HQ1 is Q. Right? Now, if you see this and substitute the value, you are going to get H is common, which clearly proves, right? So first of all, have you understood this property? If you have understood it, write UDAN first. Then we'll proceed to the solution. Yes, we are going to get there. Right, guys? So let's now that you have understood it, I am going to set certain values. The HCF will divide 3 times 2n plus 2 times 98 minus 3n. Right? So this gives me H divides 196. This gives me H divides 196. Correct. Now clearly HCF has to be less than 98. So now H divides 196. I am going to write all the factors of 196. 1, 2. So see, like what is 196? 196 is 14 square. 2 square times 7 square. So in the increasing order, we'll have to write 7. 7 times, what else? 28. No, 14 will also come. 3 times 3, 9. 9 dividers, got it. So 28, 49, 49, yes, 49, what else? 98, 196. So these two are absolutely gone. So I have all these possibilities. I have all these possibilities, right? 1, 2, 4, 7 are very easy to see. Let's see 14. If I take the value of n as 14, I will get 28, 56. I don't think we can get 14. I don't think we can get 14. Is there a way to get 14? If n is equal to, yes, let's take n as 7. If n is 7, then I have 98 minus 21, that is 77. So 14 is not achievable. We have to back check also. 14 is not achievable for sure. I don't think 49 is also achievable. 49 is also not achievable, because n is given to be natural number. 49 is also not achievable. So 1, 2, 4, 7, 28. 5 values. 5 values. 1 is achievable, man. How did you get 14, Yash? I don't think 14 is achievable. I don't think 14 is achievable. Let's see. I think, yeah, 14 may be available. Is it? Yes, I think 14 is achievable. If I put, yes, n equals 28, 56. N equals 28, then 84. 28 times 3 is 84, 14. Yes, 14 is also achievable. 14 is also achievable. So 1, 2, 4, 7, 14, 28. 6 values. 6 values. Right? 49 is not achievable. 49 is not achievable. For sure, 49 is not achievable. You can put any value of, because 49 ones are 49, 49 twos are 98, and you cannot get 49 here. Sir, I bought the book Algebra for Beginners. I have already answered it. I didn't back check. You had to. No problem. Can you write, if you have made any mistake, can you put a star on it and just write UDAN? These problems are to be double checked. These problems are to be double checked. Yes, I came to Indore. I came to Indore and then I went back. Very simple. Right? Perfect. Good. So these are very important problems of HCF and LCM. HCF, LCM, they have a very, they have very good applications, right, in polynomials also. We will discuss that once we start the algebra part. But these lectures in which we are studying the basic number theory, like these things also make a lot of difference, these basic problems, right? So now we are going to do HCF and LCM of fractions and irrational number. This is very important. Irrational numbers. Now, I am going to give you the basic definition. I am going to give you the basic definition of HCM and LCM, right? So, what do I mean by HCF of 4 and 6, right? It is very simple. In fact, let's talk about LCM. LCM of 4 and 6. What is the meaning of LCM of 4 and 6? I write the table of 4. I write the table of 6. These are multiples of 4. These are multiples of 6. The first common number which comes is called least common multiple. Subsequently, all multiples will be divisible by LCM. So, what am I saying here? LCM divides all common multiples of the given numbers. This is a very intuitive point. Given numbers. Very intuitive, isn't it? This is very intuitive. Oh, what is the answer here? In fact, it's a very simple property. Perfect. This is first point. The second point. So let's try with the same ideology. Let's try to find LCM of 2 by 3 and 3 by 5. Right? Let's try to do it. So I will write table of 2 by 3. 2 by 3 ones are 2 by 3. 2 by 3 twos are 4 by 3. 2 by 3 threes are this 8 by 3, 10 by 3, 12 by 3, 14 by 3, 16 by 3, 18 by 3, right? Now let's write the table of 3 by 5. 3 by 5, 6 by 5, 9 by 5, 12 by 5, 15 by 5, 18 by 5, 21, just a second, yes, this is perfect, 24 by 5, 27 by 5 and 30 by 5. If you see here, since HCF of 3 and 5 is 1, you have to get the integers. This is an integer, 2, 4, 6. Let me write it, 2, 4, 6. Where are the integers here? 3 and 6. So can you see that this is the least common multiple? So 6 is LCM of this. 6 is LCM of 2 by 3 and 3 by 5. I have just extended this logic here. IIT Foundation 2027 needed. It is already on. Every Wednesday we premiere the lectures. This Wednesday it may not be possible because it's New Year. So let's see. right? Right? Now there's a hack to it. Please note this now. HCF of A by B, C by D, E by F equals HCF of ACE upon LCM of BDF. Similarly, LCM of these numbers is LCM of ACE and HCF of BDF. You can write it down. You can write it down. This will be very important. This will be, believe me, this will be very, very important. It has a lot of significance in your JEE preparation also. It has a lot of significance specifically in trigonometry. How to solve your book? I find it quite hard. Which book? If it is IOQM book, then obviously it is hard. The examination is very hard. It is meant to be hard. If it is not hard, if you are not getting a IOQM study material which is hard, then you are getting a wrong study material. That is what I can say. Only 4 videos for IIT Foundation. Please take more videos. Yeah, more videos are coming. If you want to accelerate it, then you can follow my old lectures of IIT Foundation. I've already given them on YouTube. I've already taken IIT Foundation on YouTube. Done. Perfect. Now find LCM of root 2 and root 3. What is LCM of root 2 and root 3? This is a very common misconception which I want to clear here. Yash is saying root 6. Yash, use the basic definition. That is what I can say. Right? Now, what is the basic definition of LCM? Least common multiple. Let's write the table of root 2. Root 2 ones are root 2. Root 2 twos are 2 root 2. Root 2 threes are 3 root 2. Similarly, let's write table of root 3. Root 3 ones are root 3. Root 3 twos are 2 root 3. Root 3 threes are 3 root 3. Right? Now you can see there is no way to get a common multiple. And hence, LCM is not defined. LCM is not defined. LCM is not defined. And it's okay. LCM may not be defined for any two real numbers. It is not possible always. The structure, see, like the sequencing of the lectures do not match, but whatever I have given in my book, I have taught on YouTube. Are you getting it? LCM is not defined in this case. In this particular case, LCM is not defined. Right? This is a very, very important point. Please note it down. There will be scenarios in which you will be asked to find LCM of two numbers, and our childhood assumption is that LCM is always defined. It is not defined for some set of numbers. Another note, if L is LCM of A comma B, then L by A, L by B are co-prime. Can you prove it? Please prove it. Please prove this statement. Please prove this statement. If L is LCM of A and B, then L by A L by A, L by B. Very good, Sayak. Sayak is spot on. Sayak is spot on. So what Sayak is saying, sir, let's assume that A is HP, B is HQ, then LCM is HPQ. Now what is L upon A? What is L upon B? And we already know that P and Q are co-prime, right? We already know this thing. Very important. Now, I think I have been able to make this point. That the thought process which we initially used to describe LCM and HCF, the same thought process we are using to prove the properties, right? 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 Now, let's do more problems. Question. Find the smallest number which leaves 2 as remainder upon division by 5, 5 as remainder upon division by 8, and 10 as remainder upon division by 30. Right? Let's do this one. 517. Let's see. Now I am going to write whatever is written here. I have studied Euclid division lemma. So my n is 5q plus 2. My n is 8q plus 5. And my n is 13q plus 10. Now what I am observing here is 5 minus 2 is 3, 8 minus 5 is 3, and 13 minus 10 is 3. So I am going to add 3 everywhere. Everywhere I am adding 3. Now, if you see properly, I get this. In fact, we should write Q1, Q2, Q3 so that nobody gets confused that Q1, Q2 are same. Excuse me. Right? Now, if you see properly, n plus 3 is 5 times Q1 plus 1. N plus 3 is 8 times Q2 plus 1. N plus 3 is 13 times Q3 plus 1. These three statements combined says that LCM of 5, 8, 13 divides n plus 3, right? So what is the LCM here? 40 times 13 is 520. So 520 divides n plus 3. So what is the smallest number? N plus 3. What is the smallest multiple of 520? It is 520 itself. So n, this is minimum. This is minimum. And all the subsequent numbers can be calculated by adding 520. By simply adding 520. Can you please verify this thing? This is very important, right? These are certain applications of HCF and LCM. How many hours should we require to study for IOQM per day? It depends on your aptitude and the preparedness. If you are very well prepared, if your concepts are very, very clear, then you need 3 hours. If you have to invest time in building your basics also, then 5 to 6 hours. Right? Get it? See, like if you are seeing this lecture recorded and you are not being able to understand it, please see each and every step. After one step, you can pause. After second step, you can pause. After third step, you can pause. How I am implying this from these three statements, you can pause for that as well. That is the importance of self-paced learning, right? Now, let's move on to the next one. Find smallest number greater than 2, which leaves 2 as remainder upon division by 3, 5, 7, 11. So it is leaving the same remainder now. It is leaving the same remainder now. Let's see. Trigonometry, you can check my trigonometry playlist. Just write trigonometry Prashant Jain. You will get a playlist. JEE playlist. You should definitely follow my JEE playlist for trigonometry. 1157. So again, my number n leaves 2 as remainder upon division by 3, 2 as remainder upon division by 5, 2 as remainder upon division by 7, and 2 as remainder upon division by 11. Now, I can simply see that n minus 2. If you write just n minus 2, 3, 5, 7 and 11 divides n minus 2. It means n by 2 minimum is obviously 0 because everything divides 0. Every single thing divides 0, right? Every 0 is divisible by everyone. So, n minimum is 2 for sure. But can you see here that a smallest number greater than 2 is written. So, my next number is 2 plus LCM of 3, 5, 7 and 11. And since all of them are co-primes, you just have to simply multiply these, right? 1, 1, 5, 6 minus 1, 1, 1, 5, 5. So, 1, 1, 5, 7 is the answer. 1, 1, 5, 7 is the minimum number. Do you get it? Do you get it? Right? Do you get this one, guys? Are you able to get this thing? Right? Perfect. So, let's move on to the next one. Let's move on to the next one. Are you being able to understand each and every property of HCF LCM now, till now? Sir, you should take both Hindi and English lectures. I have already taken Hindi lectures. There is nothing new to teach. I see, like, you need to understand that mathematics is a very static subject. It has not evolved since last so many years, like hundreds of years. It has not evolved. The only new thing comes in the new type of problems, which we do take near the examination, right? We do take crash courses and all these things, but my full Hindi course is already available. And if you want to study live, then you can take the paid batch, right? You can take the paid batch. It is already available at 12,500. You just need to take the 1-year subscription. You need to think, if you are sincere enough, you can do freely from my already recorded lectures. If you want to study live, then 12,500 is the least amount which you can pay, right? Right? Perfect. Perfect. Right? Let's move on to the next thing. Find minimum number with property 1 mod 3, 2 mod 5, 3 mod 7. Let's find this thing. Let's find this thing. The content has its best, but not the other things. Sir, your old Hindi lectures are not good quality. Like the content is at its best, but not the other things. Yeah, that see, like I know I have a better physique now. I look much more handsome now, but you cannot do anything about it, right? It is something which changes with time. And for examinations like IOQM, you should focus only on the content. 52 is the answer, right? So there's a way to do it. Let's write all numbers which are of this type: 4, 7, 10, 13, right? Now let's see this type: 7, in fact 2, 7, 12. Now you can see that 7 is the number which satisfy both these properties. So 7. Now what I'm trying to do here is, please see this very, very carefully. 7, let me write it: property 1, property 2, property 3. So my property 1 and 2 gets combined to give me 7. The next number is achieved by adding the LCM. LCM of these two is 50. So let's write 50, let's add 15. 37, 52. And meanwhile, let's see the remainder upon division by 7. If I divide it by 7, my remainder is 0. If I divide it by 7, my remainder is 1. If I divide it by 7, my remainder is 2. If I divide it by 7, my remainder is 3. So 52 is the least number which satisfies all these properties. So this is the brute force method. Brute method to find such solutions. We'll find a much elegant method, and I don't think it is elegant, it is just, it looks beautiful, which is by the name Chinese remainder theorem. Chinese remainder theorem is something which we are going to study in the actual number theory lectures. These are basic number theory lectures. But this is how you do it. Today, I am going to give certain problems from this book. This is my book, IOQM Mathematics. This is the latest edition. You can also buy it from Amazon or Flipkart. And the things which we have done till now, congruence, HCM, LCM, HCF, LCM. So on these things, I am going to give you certain problems. The first question is this. Question. Let x and y belongs to natural number such that x square minus 2 to the power y is 2023. Find x plus y. This is 2 marker, right? This is 2 marker. 2 mark, and this was JEE Main 2023 PYQ. This is JEE Main 2023 PYQ. I just want to showcase that preparing for IOQM directly benefits you for the JEE preparation. Go for this question. What are your guesses for the next year's difficulty? I think, in my opinion, the paper is going to be of similar difficulty. The reason is very simple. They want to make the first stage very broad based. Right? When the paper was difficult, very few learners were coming to give this paper. But now more than 1 lakh learners are giving this paper, which is a very good thing. Right? If you can give me the answer to this problem, it would be good. Forty-six is what you are saying. Ah, nice. Right? Now, let me show you the reasoning of this question. One might think that there are multiple values of x plus y possible because it is a Diophantine equation. What is a Diophantine equation? If you have 2 variables and only 1 equation. But the silver lining here is I can write it as x square 2 to the power y plus 2023. Now, if y is greater than or equal to 2, 2 to the power y is of the type 4q, which means it will be divisible by 4, right? Because 2 to the power 2 is 4. So, if you take any natural number which is greater than 2, then 2 to the power y is multiple of 4. So, if I add 2023 in it, I effectively get a number which is of the type 4q1 plus 3. And we have already discussed this thing that you cannot have a perfect square of the type 4q plus 3. Not possible. Which implies that y is less than 2. And there is only one natural number which is less than 2, that is y equals 1. Right? Y is equals 1. So, when you get y equals 1, you get x square equals 2025, which is this very year, right? And hence, you get x equals 45 since it is a natural number. So, 45 plus 1 is 46. 46 is your answer. 46 is your answer. Right? If you have followed the solution, please write UDAN so that we can move forward for the next problem. Please write it down so that we can move on to the next problem. Also, note these problems in your classwork copy and also note the solutions if you were not able to do it. So Sonal got it, Ojas got it, Sayak got it, among you got it. I don't know the name of among you. Perfect. Perfect. At least some of you have understood the reasoning behind this problem. So let's move on to the next problem. Let's move on to the next problem. Okay. Let x and y be positive integers. Positive integers such that L plus H equals 91. L and H are LCM and HCF. Find number of possible x comma y such that x is less than equal to y. Please do it. Please do it. 4Q. Anu Sahu, it seems that you have not taken my initial lectures of number theory. Please do that so that you are able to understand these terminologies. What is 4Q, right? 4Q means multiple of 4. Sir, I am in 8th preparing for IOQM. I have completed class 9th and 10th geometry from R.D. Sharma. What to do further? Then you can directly pick my book and you can study from it, it seems. So you are saying that x and y, like there are 45 pairs. I don't think this is the correct answer. I don't think this is the correct answer. Two. Let's see. Sayak is saying only 2, sir. Right? See, like some of you are trying to do this. Sir, L and H are natural numbers. So L will be, since L is greater than H, so L is 90, this is 1. This is 89, this is 2. This is 88, this is 45, this is 45. So in total 46 solutions. This is completely wrong. 46, 45. This is completely wrong. Because HCF and LCM have a relation and you have to follow that. See, let's assume that x is equal to h times a, y equals h times b. This is what we did. While proving for the notation for LCM and HCF, we noted that x can be assumed as h times a, y can be assumed as h times b, and in this scenario, your HCF of a and b is 1. In this case, your LCM becomes HAB. So what is given? L plus H equals 91 means H plus HAB equals 91. Right? So this gives me H 1 plus AB equals 91. Right? Now let's make the case. This means that H divides 91. So we will make case on H. If H is 1, this means your HCF is 1. This gives me AB equals 90. Right? Because 1 plus AB becomes this. Now we have to factorize 90 in such a manner that A and B has to be, and since see, like I have assumed X to be less than, so A has to be less than equals B. So this is A, this is B, right? I can assume this as 1, this as 90, right? Perfectly fine, because their HCF is 1, LCM is 90. I can assume A to be 2, this to be 45, which is okay. Now this 3 and 30, this is not acceptable because my A and B are not coming out to be co-prime, right? I have to skip 4, 5 and 18, again valid. 6, 15 is again not valid. 6 and 15 again not valid because these two numbers are not co-prime. 7, 8, 9 and 10. This is also valid. This is also valid. Right? So there are 4 cases in this scenario. 4 cases in this scenario. Right? Right? Their LCM is 90, HCF is 1. So 4 cases in this scenario. My next case is H equals 7. Right? So 1 plus AB equals 13. So AB becomes 12. Now since my A is less than B, so again 1, 12, 2, 6 not possible because you need co-prime. 3, 4 again possible. And yeah, that's it. So 2 cases here. 2 cases here. Right? Let's look at further cases. Case 3. H equals 13. When your H is 13, this means your 1 plus AB equals 7 and your AB equals 6. So 1, 6, 2, 3. 2 cases here. Right? If you want to verify, just verify. Right? Your HCF is 13 and your another number is 78. Right? So your LCM becomes 78, HCF is 13, 13 plus 78 is 91. Right? This is, and the last case is your HCF is 91, which I don't think is possible since your AB becomes 0, which is not possible. So 2 plus 2 plus 4, 8 cases. 8 cases. Am I making sense, guys? This is actually at least 3 marker. This is 3 marker. Since you have a lot many cases here, this is 3 marker in the new regime, right? In 22, if you talk about 2023 level, then this won't be in 3 mark. It will be a 2 marker problem. But in the new regime, it is a 3 marker problem. Lakshya is saying, sir, I got 30 marks from Haryana. I did not get the selection. I missed it by 1 mark. Our full sympathy is with you, but there is no sense in spamming it, right? You won't get selection by spamming. Just focus more, prepare hard for this year's IOQM, right? The starting of my answer was like yours only, but then I messed up completely in making the cases. See, like now this is the story with many of the learners. I would like to address this question here. What Sayak is saying. See, like what IOQM does for you, it gives you the algorithm for solving. Majority of the problems in IOQM are multi-layered questions, right? So basically, you have to assume certain things, right? So this is the first stage of the problem. Then you have to carefully think what are the different cases. So this is where the problem This is where this problem get converted into into an equation, and this equation gives you the thought process, and then you have to systematically take the cases in the increasing order of h. I have taken h equals 1. Since h is factor of 91, there are only 4 factors of 91: 1, 7, 13 and 91. So I have simply taken the cases. If you do it systematically, then you will not miss any case, right? Perfect. Right? Perfect. Now, let's solve it. Find the smallest number A, B, C, D, E, 5 digit, so that A, B, C is divisible by 4. It is a 3-digit number. It is not a multiplication. It is a 3-digit number. B, C, D is divisible by 5 and C, D, E is divisible by 3. Let's do this. Let's do this, guys. Lakshya is saying, do not waste your time in examinations like IOQM. I'm pretty sure that this learner, if he has actually prepared for IOQM, even if you are not selected due to these reasons, right? These are unforeseen reasons. Obviously, IOQM authorities did take initiative to resolve it, and they will be resolving it in the next years also. Even if you miss the selection list, the preparation itself is so rewarding. Just imagine a learner doing these problems in class 9th and 10th, and imagine him facing JEE problems of mathematics. Mathematics is the most difficult subject in JEE preparation. If any learner has done IOQM preparation in 9th and 10th, he will be very, very ready for JEE preparation. No, I do not think so, Lakshya. I do not think that it is a waste of time. You will see. You are we will see. We will look at it. Pradyumna will look at it. Find smallest number A, B, C, D, E, 5 digits, so that ABC is divisible by 4, BCD. I missed it. Using digits 1, 2, 3, 4, 5. Exactly once. This was also given. I missed this information. Otherwise, the answer is like 10,003. I agree. Sir, you remember me? I am Amal from Kerala. Yes, I'll remember you. See, with this initiative, we have learners from Kerala as well. Otherwise, my distribution was like it reached to the further east. By the way, guys, I am visiting Agartala from 13th to 17th of January. If you know anyone who is in Agartala, then you can definitely ask them to meet me. Okay, Lakshya, we'll remember your name. 12453. Let's see. See, 1, 2, 3, 4, 5. Here you will definitely get 5 for sure. Right? Here you will definitely get 5 because BCD is divisible by 5. It means your unit digit should be divisible, should be 5 or 0. Right? I will keep 1 here because I have to find the minimum number. Right? Now one way to do it is, C is either 2 or 4. Right? Right? So I'll try to keep 2 here to get the minimum number. Now this makes my 3-digit number 124 divisible by 4. 245 is divisible by 5. 453 is divisible by 3. And this is how I get the number 12453 is the minimum number. Right? This is the minimum number. Right? This is the minimum number. Why are you talking in English? Very good. Nice, nice, Harsh. I like your ignorance. This is, I believe, 10th or 11th lecture of IOQM English course. I think you thought that this is a course in which English will be taught. And in many schools, English is being taught in Hindi. So you thought that, anyway, let's move. Why not 0? Why not 0? Because 0 was not given to us. Right? Using digits 1, 2, 3, 4, 5 exactly once. It was given to us. Yes, SEHSS is correct. SEHSS is correct because all these things are 3-digit numbers. Then 10,003 is not the minimum number. Right? So this means that I think 112 because this is divisible by 4, right? 1125. In fact, 0 also. 0 is okay. 11201. This is the minimum number. Can you confirm? If this restriction is not there, then is it the minimum number 11201? 11201 is the minimum number. Do you all agree? Do you all agree? Do you all agree? 11201 is the minimum number, I think, if there is no other restriction. Yash is not present today, Yash Pillai. He used to attend all the lectures. Perfect. Let's move on. Let's move on to the next problem. Let's move on to the next problem. Find remainder when 300 times is divided by 9. Is divided by 9. It is based on the divisibility rule of 9. Yes, Amal, you can join it. You can definitely join Center's live program or foundation. What is the answer to this problem? Six. So this is a very important thing. See, like 2 is getting repeated 300 times. Now what I will do, first of all, I will find the sum of digits. So I'll represent this with S of n. S of n denotes sum of digits of n. So can I say that it is 600? 2 is repeating 300 times, which means 600. Now, if I see it properly, I can write it as 594 plus 6. Why I am writing this? 594 is divisible by 9. So 222,22000. This is 297 times. And I am writing the remaining number as 222. So this number is divisible by 9. I am writing the remaining number as 216 plus 6 because this number is also divisible by 9. So this whole number is divisible by 9. Your remainder is 6. In fact, you can write this theorem that sum of digits of n and n leaves the same remainder upon division by 9. You can write it. Sum of digits of n and n will leave the same remainder upon division by 9. You can write it. This is a very important theorem which is used in non-routine mathematics. Do teach for JEE. I do teach for JEE. Every year, I get this surprising thing. Majority of the people know me because of my IOQM, and they do not know that I teach for JEE also. I teach for JEE also, but in Hindi only. I mean, like, I write everything in English, but I teach in Hindi. Right? Nice. Anyway, let's move on to the next problem. Have you written it? Can you write UDN so that I can move forward? Perfect. Sir, I got 6 marks in RMO 2024 for Assam region. Couldn't able to qualify. Will try. Nice. This is the attitude which is required. If you do not get it, restart. Next problem. Next problem. Let just a second. Let n, let s equals 1, 2, 3, 83. Find number of n belongs S such that 2 to the power n plus 1 is divisible by 3. Divisible by 3. Let's do it, guys. Let's do it. Dinesh is saying I got 30 from Rajasthan. In Rajasthan, the competition is too high, I think. Okay. 42 is the correct answer. See, like problems like these, you do them by pattern. So, you will see that 2 to the power n is of the leaves 2 as remainder mod 3 if n is odd. Right? So 2 to the power n leaves 2 as remainder mod 3 if n is odd. 2 to the power 1, take case of 2 to the power 1, take case of 2 to the power 2. Similarly, 2 to the power n leaves 1 as remainder mod 3 when n is even. And this is very intuitive to think, right? There are only two remainders possible, 1 and 2. Perfect power of 2 is definitely not divisible by 3, right? 3 is a distinct prime number. So, this is your case. So, n has to be odd. So, 1, 3, 5, ... 83. Right? So, these are 42 odd numbers. Okay? These are 42 odd numbers. Right? This is the one. Perfect. Let's move on to the next problem. Find number of integers from 1 to 1200 which are not divisible by 2, 3 or 5. Right? There is a lot to be taught in this particular question. First of all, I would like you to attempt this so that I can explain it. I'll give you 4 minutes to solve it. There is no timer here. Okay. No problem. Why almost all problems have relation with 42? It's a mere coincidence. It's a mere coincidence. What's the hundredths digit of 2011 to the power 2011? It is very easy problem. You just have to find mod 1000. AP, but it will take some time. Typical PNC stuff. See, like, if you do not get the right answer, then it will be very difficult. See, like, please try to understand the question properly. It is written which are not divisible by 2, 3 or 5. So the strategy is very clear. The strategy is very clear. Let me write the strategy. Let me write the strategy. Strategy. M equals number of integers divisible by them. Then answer is 1200 minus m, right? This is a very simple thing to understand. This is called complementary counting, right? So you have counted the complement of something, and when you subtract that complement from the original number, you get the answer. Perfect. So now I am going to write something here. Number of multiples of k from 1 to n is the greatest integer of n upon k. What do I mean by greatest integer? Greatest integer of x is biggest integer is smaller or equal to x. For example, greatest integer of 3.5 is 3, greatest integer of 3 is 3, greatest integer of minus 3.5 is minus 4, right? This is the definition of greatest integer. right? So if I take the multiples of 2, then it will be 1200 upon 2. Since this number is 600 only and greatest integer returns the integer value if it is integer, so this is 600. Multiples of 3 in similar fashion is 1200 upon 3. Are we getting till this point? This is my question to you. Are you getting till this point? Are you getting till this point? This is my question. Please tell me, guys. Nice. Pi used here, principle of inclusion exclusion. Nice. Yes, it is good that you know these things. So this is 600, this is 400, this is 240. But there's a problem here. There's a problem here. Certain numbers are repeated. For example, every multiple of 6 is counted here as well as here. So we are going to make a very nice diagram. Let's represent this circle as multiple of 2, this as multiple of 3, this as multiple of 5. This is called Venn diagram. So this particular number I have to subtract, right? This is multiple of 6, right? So on the next page, I will calculate multiple of 6. 1200 upon 6. Multiple of 10. 1200 by 10. 120. Multiple of 15. And I'll tell you what is happening here. 80. Multiple of 30. This is 40. So now what is happening? Please see here. I am making a Venn diagram here. This is multiple of 2. This is multiple of 3. This is multiple of 5. So this is actually multiple of 30. Because this particular region is common to all. So this number, let me write this number. Let me write this number. This is multiple of 30. This is 30. Right? Now, if I see this region, this particular region, this whole region, let me outline it. This region is common to 2 and 5. Also 3, but it is common to 2 and 5 categorically. So, every number divisible by 2 and divisible by 5 is divisible by 10. So, these are 120 numbers. Out of these 120 numbers, 30 are written here. So, can I write 120 here? Can I write 120 here? Can I write 120 here? Oops, my mistake. This is 40, this is 40, this is 80, this is 80. My mistake. It was my mistake. I have corrected it. Now, do you follow this Venn diagram? 40 numbers are divisible by 2, 3 and 5. 80 numbers are divisible by 2 and 5 but not by 3. Are you following it? Are you following it? I do not want you to go into the deeper concepts of set theory, right? I do not want that. I just want you to understand it logically. I just want you to understand it logically. Now, this is multiple of 2 and 3 which are not divisible by 5. So, multiple of 2 and 3, 200. But out of these 200, 40 are divisible by 5 as well. So, I can write 160 here. Similarly, this multiple of 15 divisible by 3 and 5. Out of these, 40 are divisible by 2 also. So, 40 here. This is interesting. Are you following till here? Are you following till here? Now, only this region is remaining. This is the region which represents the number which are divisible by 2, but neither they are divisible by 3 nor they are divisible by 5. So, if you add them, this is 280. So, 320 is here. In total, if you remember, 600 integers were divisible by 2. So 320 here and 280 here. Again, 240 here. I think 400 was there. So 160 here. This is how much? 80 plus 80 is 160. 160 and 80 here. Right? 240. Perfect. Now, can you make sense of this? Can you make sense of this? Can you make sense of this? Are you following this Venn diagram? This is the Venn diagram of 1200 numbers. 1200 numbers. Out of these 1200 numbers, 320 are divisible by only 2. They are not divisible by 3. They are not divisible by 5. Only by 2. This region represents number divisible by 2 and 3 but not by 5. This region represents number of integers which are divisible by 2, 3 and 5. Right? So now add them up. Let's add them up. 320. This is 600. 600 plus 200 is 800. 800 plus 80 is 880. So 880 is covered. Now what is asked from us? Neither divisible by 2, nor divisible by 3, nor divisible by 5. So this means 320 comes here. And this is our answer. This is our answer. This is our answer. Right? This is the answer. Is DLP paid? Obviously DLP is paid. While like, do you know any coaching which gives you the study material in hard copy for free? It requires printing cost, right? But we have kept it very minimal. We are just recovering our cost. Perfect. Let's get on. Let's move. Let's move, guys. Let's move. Let's move on to the next problem. Let's move on to the next problem. Right? Find remainder when 13 to the power 1 plus 13 to the power 2 plus 13 to the power 3 plus 13 to the power 2025 is divided by, what do I write it? 5. Let's do it. Let's do it. We want 5 markers. I will give you, certainly I'll give you a 5 marker. Don't worry about it. Should we practice AIME problems for IOQM? Yes. That is why I included around 150 problems of AIME in my book. Find the remainder. So see, like again, these problems are pattern based, right? So we have to follow the unit digit here. We have to follow the unit digit here. 13 to the power 1, the unit digit is 3. I am writing unit digit here, okay? And there will be some pattern. 13 square, the unit digit is 9. And in fact, we have categorically mentioned this thing that we do not have to look at this digit. We simply need this, right? So 13 power 3 is 7, 13 to the power 4 is 1. After this, the cycle repeats. 3, 9, 7, 1. If you add these numbers, 16 plus 4 is 20. 16 plus 4 is 20. Again, 16 plus 4 is 20. What is happening here? Please, you need to understand this thing. So, I am making a group of 4 powers. 4 powers, 4 powers here. So, I will group till 13 to the power 2024, and my 13 to the power 2025 is left alone here. This is 3, right? 13 to the power 2025 gives me 3 as the last digit. This is what we have done in cyclicity lecture, right? Now, if you see properly, your 20, 20, 20 is getting added. Now, how do you see, like if you add these numbers, hypothetically, if you were to add these numbers, you will have, these are 2025 numbers written in this format: 13, 169, 2197. I'm not writing the further powers. I am just going to write the unit digit, right? So if you were to add these numbers, you would add the unit digits: 20, 20, 20. These many times 20, and there will be a last 3 here. So since 20 is getting added, 20 multiplies by any number gives 0 as the unit digit. So 0 plus 3 is 3. So your unit digit is definitely 3. And for the divisibility with 5, only unit digit is required. So 3 is your remainder. Are you getting my point? 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 Right? Right? This is how to develop your thought process in IOQM problems. IOQM deals with your number sense a lot. You need to develop it, and that is why I tell my learners that preparing for IOQM gives you a definite edge in preparing for JEE. right? Perfect. Let's move on to the next problem. Let's move on to the next problem. This is the last problem of the day, right? A, B, C, D, E, F is minimum 6-digit number, so that F, A, B, C, D, E equals 4 times A, B, C, D, E, F. This is multiplication, right? 4 times. Find A plus B plus C plus D plus E. Do it. Answer is 27. See, like you wanted 5 marker, and yet you are not being able to answer this question. This is obviously based on casing. Right? So 1, 2, 3, 4, 5, 6 times 4. 1, 2, 3, 4, 5, 6. Right? Right? So clearly you need to understand this cannot go beyond 2. If this is 3, this becomes a 7-digit number. Right? So this can be 1 or 2. This can be 1 or 2. That's it. Right? This can be 1 or 2 only. So let's assume that this is 1. So then this is 1, since you have to take the minimum number. So I'll definitely take 1 here. 1 is here, so 1 is here. Right? Because your digits are getting like in this format. Okay? Okay. So 4 times 1. The maximum you can get carry is, just a second, let me think on these lines. The maximum that you can get carry is 3. So the maximum number you can get here is 7. and this number was present here, right? So what are we doing? So let's assume that this number is 1, 2, 3, 4, 5, 6. We are putting this 6 here, right? This is what we are doing. This is what we are doing. Okay. This is what we are doing. This is what we are doing. Right? 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 This is what we are doing. Okay. So see, like we can take 4 as this number, right? If we take this as 4, 4 times 4 becomes 16. If this is 6, this becomes 6, right? Carry over 1. 4 times 6 is 24. 24 plus 1 is 25. This becomes 5. 4 times 5 is 20. 2. 2 carry. This becomes 2. 4 times 2 is 8. 8 plus 2 is 10. You get carry here, 1 here. You get 0 here. 4 times 0 is 4. 4 times 0 is 0 times 1 is 4, and 4 times 4 is this. So is this your number? Can you check it? Can you check it? Is this your minimum number? Because I have to see, like, the minimum number I could take here is 4, right? Because 4 times 1 is 4. I'm again checking. 4 times 4 is 16, carry over 1. So this number comes here by this analogy. 4 times 6 is 24. 24 plus 1 is 25. 2 gets carry here. And I'm using these digits here then, right? This 5 digit is this 5 digit, right? Is this the number? Can you all check? Can you all check? Can you all check, guys? So this is your smallest number. This is your smallest number. So 1 plus 0 plus 2 plus 5 plus 6 plus 4, the answer becomes 18, right? This is 18. Got it? Got it? So I hope, guys, you like the session. If you are doing it in recording, please do leave a comment. In the comment, you can write how many questions